Mr. Chaturvedi and Deshpande, Dr. Pant. Mehrotra is not there, but I think he'll be joining. Speakers, I think the subject that we've chosen for today's discussion and is on emerging technologies. As we earlier discussed, when we go into any literature on emerging technologies, unfortunately, there's an overemphasis on IT. And we thought that let us try and look at a different way and look at technologies that are required in the current industry, petroleum and steel, and maybe even cement, as to how do we use the newer technologies to and enhance production, enhance efficiency, and maybe even make it even greener as far as processes are concerned. So with this, we initiated this. We had one or two meetings amongst ourselves, Mr. Deshpande, Dr. Pant, myself, Professor Malhotra, and we zeroed down to say that let us look at petroleum, petrochemicals, gasification as a source, as something leading to, say, steel manufacturing or affecting cement. So with that in mind, we kind of looked at various persons who could be eminent speakers on the subject. And we are very lucky to have a good panel today. Dr. Vedya, Mr. Narang, Parthamitra, and I think we have Manish Sandhya, and we will be joined soon by Mr. Piyush, who is actually still working in Coal India, is an MD of two of the companies which government has set up for coal gasification to chemicals. So this is where we are, and we really are looking forward to kind of listening to the specialists and the speakers. Just to add on that Piyush, he'll be joining us around 2:15, 2:20 as he has a meeting which he's attending. So, and he has already conveyed that to me that he'll be joining soon.
Okay, fine.
With that, I would like to leave the floor to Mr. B.K. Chaturvedi, who's our chairperson, to say a few words before we plunge into the main subject and ask our speakers to give their presentations. Mr. Chaturvedi, sir.
Yeah. Well, thank you, Alok, and thank you all the invitees, first of all, for being here and participating in this webinar. In the Lovraj Memorial Trust, we are very keen that we try to contribute to at least to the best of our ability and bring on one platform all the technical experts who bring in new ideas, can throw in new experiences and tell us more about how the world is moving in different areas. And I'm very glad that apart from the subject chosen, which is petrochemicals and coal gasification and technologies in the oil sector, these are areas which are extremely important because after the emergence of the need for clean energy, it has become important that we talk of new technologies which can give us more money for the buck and also tell us how we can have cleaner methods. So essentially, I'm very glad that we have a very distinguished panel today, people with oceans of experience who will tell us how they are doing and how people can move forward. And this exchange of ideas, I'm sure, will help us in moving another step and taking another step both in the private sector and in the public sector
Join as a
for
panelist.
development of these areas for
अरे
cleaner
आप join as a
energy
panelist,
and for development
तो
of
आपको link
more
भेजा ना?
petrochemical sectors and oil sector. With this, I add my own word of welcome to all the participants and hope that you would have a very fruitful session whose recommendations and whose exchange of ideas would help you in moving forward in your areas where you are working. And thank you very much for coming and joining us in this webinar.
Thank you. Thank you, Chaturvedi sir. Let me start the formal proceedings of the webinar today. I'll just go through the list of speakers that we have, and then I'll go through a round of introduction of each speaker before he starts his speech. We'll have a keynote address by Mr. S.M. Vaidya, former chairman of Indian Oil, after which we'll start the formal proceedings of the webinar. We'll have Mr. Manish Shandilya from Engineers India Limited talking about refinery petrochemical integrations and new as concepts. We have Mr. Rajiv Narang, Executive Director of the Process Economics Program from S&P Global, who will talk about disruptive technologies and public policy. We have Dr. P.P. Maitra, President, Strategy and Initiatives from Reliance Industries Limited, who will talk about future of olefins. We have Dr. Piyush Kumar, Managing Director of Bharat Coal Gasification and Chemicals and former Director of Technical of Ministry of Coal. After Dr. Piyush Kumar, we have Mr. Manish Singla, Head Minerals Options from Jindal Steel and Power, to talk about coal gasification policy initiatives and challenges. So this is the lineup for the technical presentations today, and we begin the round of introduction of all the speakers today, beginning with Mr. S.M. Vaidya. Mr. Vaidya is the former chairman of Indian Oil Corporation, and he has been a very strong votary of India's unique energy transition blueprint to ensure energy justice for our nation's vast population. Mr. Vaidya is a leading global energy technocrat with expertise in crafting solutions for green energy transition. He has been a prominent contributor to the global discourse on energy security and sustainability. His commitment to sustainability is evident in Indian Oil's goal when he was the chairman, he laid it down to achieve net zero operational emissions by 2046 with an investment of over $24 billion. He has spearheaded initiatives in green hydrogen, biofuels, and electric mobility, including the launch of India's first green hydrogen fuel cell buses and establishment of Asia's first 2G ethanol biorefinery. Apart from his professional and other interests, Mr. Vidya is also dedicated to social transformation through sports, leading programs that have positively impacted over 7,000 inmates and juvenile offenders. He has fostered employee well-being and gender equality initiatives during his tenure at Indian Oil. So with this brief introduction, I know there's a long introduction I can go on, but I would like to hear, and so everyone would like to hear your views on the current energy scenario and the transition that we are all looking forward to. Over to you, Mr. Vaidya.
Thank you, Ajay. And first and foremost, thanks to the Lovraj Kumar Memorial Trust for inviting me. I respected Mr. Alok Verti, Mr. B.K. Chaturvedi, and all the distinguished panel that is already joined virtually. Actually, this program reminds me of a program that is available on YouTube about the 10 most emerging technologies which the MIT, the Massachusetts Institute of Technology, they highlight every year. So every year they highlight the 10 most emerging technologies, and then they take a stock of whatever they have said in the past, whether these technologies have actually matured or not, or was it just a flash in a pan. So I think this is a good beginning. We can continue this as a series, so whatever we are saying today, how it is panning up in the days to come, we will know exactly.
Okay.
Secondly, I want to start my talk. I mean, there are a lot of emerging technologies, but what really matters to India is energy sovereignty. Today, we are 88% dependent on crude, more than 60% dependent on gas, and these numbers are only increasing because India has got a very healthy 3.5% per annum growth rate in petroleum products. So this is only going to go up And so what it means is over a period of time, we will be totally dependent. We already are on the imports of crude and natural gas. Now, what we have seen in the recent past, the geopolitical unrest, not only the geopolitical unrest, but even the passage of crude to India, even that is also very, very important. Like the what we have recently seen, the Gulf of Hormuz, what it was under attack. So I think India has to really think about energy sovereignty as its number one goal. I would rather put it even one step ahead of green transition, because green transition is fine, but first and foremost, we need an energy sovereignty for a population of 1.4 billion Indians. Now, what are the pillars of energy sovereignty for a country like India? First and foremost, I will say that India is blessed with huge amount of coal, 300 billion tons. Out of that, 150 billion tons is already proven, and balance is yet to be proven, but it's there. So it stands among the top 3 to 4 coal producers in the world. So I think we need to leverage this particular asset for us to inch our way towards energy independence and energy sovereignty. Then secondly is waste management. Our country is sinking in waste. 68 million tons of municipal solid waste generated every year. 68. Out of that, only 50% gets processed. Balance 40, 60, I mean 40 million tons goes into landfills. This is something that is just not sustainable. So one is waste. This is only the municipal solid waste. Plus we have 10 million tons of plastic waste, and we have 2 million tons per annum. I'm talking of per annum of e-waste. So the waste figures are only going up by the day. So I think something that tackles the energy sovereignty and something that manages waste. For me, these are the emerging technologies that are really going to make a difference for a country like India. Then again, in the pillars of energy sovereignty, apart from coal, biofuels. Biofuels is one big story that we have unearthed in a good way. We have already 20% blending of ethanol in petrol, but I think there is more to be done. And this is something that we really need to go high on this. And one of the main advantages of biofuels, which is not really being projected, is that the biomanure which comes out of the biofuels. Suppose we take a compressed biogas plant, the yield of the plant is just about 10% of biogas, but 30% of that yield is biomanure. Now, this biomanure has got a organic carbon content of 25 to 30%. Today, in the northern part of the country, that is Uttar Pradesh, Punjab, Haryana, which are very high yielding states, 40% of our grains come from these three states. The soil in this particular three states is actually dead. The organic carbon is a barometer by which we measure the soil health. It is just 0.1% is the organic carbon in these states in the soil. Whereas a healthy soil, it should be between 1.5 to 2%. So I think we are only flogging these soils by excessive use of chemical fertilizers. And because the soil doesn't have organic carbon, 50% of the chemical fertilizers gets washed off, polluting groundwater and polluting river water. And of course, as we all know, nearly 1,80,000 crores is the single biggest subsidy for fertilizers. So I think this particular aspect is also very, very important for a country like India, how to regain the health of the soil for these three high yielding states. In fact, it is bad all through, but these three states I'm particularly highlighting because it's just 0.1%. It's practically nil. And this particular organic manure is just about 25 to 30%. The right blend, if we can have it with the chemical fertilizers, I think we can make it. Now, coming back to the topic, one is the waste management, in which we have an emerging technology of plasma gasification. Now, when I was in Indian Oil, we had tried out a plasma gasification plant for Delhi, but it didn't work out because of the simple reason that we could not have the moisture content in the waste less than 30%. Now, this is a particular excellent initiative where everything is incinerated. Whatever the municipal solid waste is there, once it is properly segregated, we incinerate it at a temperature of more than 5,000 degrees centigrade. and we can create syngas, we can create whatever we want. Once we get syngas, we can do a whole of things. But again, we are at the beginning, at the fundamental level, that we are unable to segregate our waste. So I think one is the plasma gasification. I think we need to invest more in this. And ultimately, unfortunately, we had to drop that project because it was not coming economically viable. So I think over a period of time, we need this particular emerging technology to be more and more looked into, because that is going to really solve our issues of municipal solid waste, which is a prime problem for the entire nation. After that, we come to the coal gasification. Here I told you that India has got nearly 150 billion tons of coal reserves, as much as China. But I'll just give you the figures. China has got 340 million metric tons per annum of coal gasification capacity today. And they have got a plan of 500 million metric tons of coal gasification by 2030. And already the work has started. In India is just 15 million ton, 1.5, and that too is mostly in the steel plants wherever it is required for making coking coals. So we have barely scratched the surface, and we have got a target of 100 million tons by 2030, which is of course, I mean, I don't know whether it will really achieve it or not, but I think this is one particular area where we are so sorely lagging behind China. And China, one of the main reasons why they are going for coal gasification and now electric mobility in a very big way is to reduce the dependence of crude. Same thing, China is in a very similar position like India, wherein they are mostly dependent on imported sources of crude oil and gas, and they've taken a very conscious call to reduce the import dependence. And one of the ways is coal gasification, and they're really exploiting it. You can imagine 340 million tons per annum is the coal gasification capacity, which will go up to 500 million metric tons. So I think coal gasification is one area. I think we all need to understand that this needs to be really pushed in a very big way. If at all, we have to have some semblance of energy sovereignty. Now, what are the other areas in coal gasification? There are hyperspectral imaging and laser-induced breakdown spectroscopy, the next generation extraction and gasification, in which we have underground coal gasification, which is nearly 40% more energy efficient than the normal coal gasification. But here I want to add one thing, that since we are just at the beginning of the curve for coal gasification, we should mandate carbon capture as a integral part of the coal gasification, which China did not do. So I think we can learn from what the China has not done, and their CO2 emissions really went up because coal gasification is an extremely CO2 intensive process. So I think we should have coal gasification with carbon capture, utilization, sequestration, CCUS as an embedded part of this entire story. Then coming down to the synergies with the renewable energy. I mean, we should have concentrated solar thermal projects for coal gasification along with renewables. These are new areas, and we really need to push them forward in a very big way. One very big aspect that is coming up these days is the coal to critical minerals. US has earmarked, they have indicated a market of $200 billion market from coal to critical minerals. That is basically scandium and gallium, which are extremely important for the transition of the energy wherever you use them. And this is something that we really need to look after that. And US is going in a very big way to manufacture these from coal to chemicals, critical minerals. Now, coming down to other aspects, what we were discussing, one is, I will not take more time. One is then the distillation, because this is basically talking about distillation also. We have heard of membrane distillation for a very, very long time. The membrane distillation, instead of the conventional distillation, it gives a nearly a 50% energy efficiency benefits. Let us try to clearly understand that the oil industry is trying to grow green in a way that we try to make more products by minimizing the scope 1 and scope 2 emissions. So I think this distillation by membrane, I think now ExxonMobil and Imperial College of London are doing a pilot project for this particular thing. And they are basically doing it for the lubricant range of products, not for the lighter grade of products. So I think this particular area that can be really taken up forward in a very big way. Then in petrochemicals, the catalytic breakthrough for precision chemistry, then the chemical recycling, aluminum sorted waste uncycling. I mean, the gamut is very large, but I think we should be mostly concentrating, if you take my thing, for more and more technologies that are coming up in coal gasification. We should be really promoting them in a very big way. And whatever R&D efforts are being there in the country, I think we need to really support them in a very big way. I think the voice of Lovraj Kumar Memorial Trust is heard. It can be a good takeaway point that we need to do these things in a very big way if India has to achieve energy sovereignty in some form or the other. Thank you very much.
Thank you, Mr. Vaidya, for giving a very, very inspiring talk. I know these thoughts that
Ajay, you are muted.
Ajay, you are muted, Ajay.
Sorry. Okay, thank you very much, Mr. Vaidya, for your inspired speech and some new thoughts that you have put, which are as a result of your extensive experience in leading a major engineering company, and also thereafter in overseeing it as an outsider as to what it should do and where it should venture towards. So whether it's energy sovereignty that you talked about, which covered emphasis to be laid on utilization of coal resources or utilizing the wastes that are being generated, or focusing on biomanure to improve the soil productivity, and some of the new initiatives that you thought of promoting, like plasma gasification and all, are definitely underground coal gasification are definitely the areas for future work. But you have focused primarily on coal gasification as a need of India to go for energy sovereignty. And in this context, I would like to welcome our first speaker from the technical conference program, Dr. Kumar, who is presently the Managing Director of Bharat Coal Gasification and Chemicals Limited, who is actually the man in the seat who is implementing a coal gasification company and coal gasification venture. So many of your points about what China has done, where they missed out on, and what India should focus on, probably we'll get to hear from Dr. Piyush Kumar in his presentation about what they are planning to do for monetization of the vast resources of coal that we have. So Dr. Piyush Kumar, just a brief introduction. He is currently the Managing Director of Bharat Coal Gasification and Chemicals. He is a BTech in mining and a PhD, both from the Indian School of Mines, Dhanbad. And he has co-authored various policy papers, such as the underground coal gasification policy, which Mr. Vaidya mentioned as one of the requirements for future for India, reject policy, star rating policy, and national mission for 100 metric ton coal gasification by 2030. These are some of the papers and policy papers that Dr. Piyush Kumar has authored. And he's a recipient of Sir John Dunn Medal from the MGMI, the IMA Golden Jubilee Award for coal mining, and Professor Ajay Ghosh Memorial Diamond Jubilee Award from IMA Germany. And we would like to hear from you, Dr. Piyush, about your experiences. Since you wanted to leave a little early, we would like to request you to take at least one or two questions which might come in the Q&A box after your presentation. For the other speakers, we are asking them to stay back till the end, and we will take the questions on their presentation towards the end. I would also like to invite, if someone has any questions on Mr. Vaidya's presentation. Mr. Vaidya, I hope I have your consent for that. Okay. If you have any questions on Mr. Vaidya's presentation, you can post them also in the Q&A box. Please make sure to write the name of the person or the presenter to whom the question is addressed. Okay, so over to you, Dr. Piyush Kumar. Time is about.
Thank you, sir. Thank you for accommodating my time.
Please carry on.
I think I'm audible.
Yes, you are audible, sir. Go ahead.
Yeah. So I must thank you, sir, for accommodating my timing. Actually, I have to attend a meeting from 3 onwards. Okay. It is always good to start from where Vaidya sir has given directions, and I will be covering one part of his thought which he has given in this meeting. It is on coal gasification. Yeah. I was in Ministry of Coal as director when we made this policy paper for. This was a vision of 100 million ton coal gasification. Let us not take it as a target. It was a vision, and vision has certain challenges. And that's why the document was made, so that the government, the companies can take up certain actions so that they can mitigate the challenges. So what are the challenges before us? What Vaidya sir has told you about the coal in China and now the coal in India. Basically, it is not like-to-like comparison. It is just apple and mango. What happens that China is gasifying coal, which has an ash percent of 8%. 8% ash coal. And the better quality coal, they are mixing with 8% ash coal to some 30%. And the maximum ash which they are gasifying is 15% ash. This is the first challenge the India is facing, because the best quality coal available is 24% ash. You know, ash, most of the technology which is being run in China is in-trend bed technology, in which the fusion temperature of gasifier is, the fusion temperature of coal is 1000 and the gasifier temperature is 1500. So most of the ash is melted in this. So that's why the challenge is that we have to find out a solution to it. What Coal India has done, Coal India has tied up with BHEL, with KL, and VPCL, and we have formed 3 companies to overcome these challenges. So there are 2 challenges what Government of India is facing. One is the technical challenge, which I told you about the percentage of ash. And the second challenge is the financial viability of the project. Because initially, most of the project is very new, and things means most of the proprietary items will be imported from Europe or from China. So for the initial project, there are a challenge for uh, financial viability. So and the third challenge was always there, the availability of coal. So after this recent document, government has worked on all 3 fronts. First is the availability of coal. So government has given a policy provision in which they have given certain rebate also for the commercial auction of blocks. Now they have also come up with a policy that you can get coal for coal gasification at the cost of power. So those challenges are being addressed. About the financial viability of the project, government has again come up for rupees 8,500 crore for initial 13 projects, so that the initial projects doesn't think much, and they can come up with the DPR which is financially viable, which can give 12% IRR, so that the project can be approved. These 2 challenges has already been taken up by the government, and the third challenge is the technology. Right now, under the government scheme, apart from Coal India, 3 private sector has also come up. They have taken the government support for taking up the project. So the challenge which we are now facing is that the coal gasification technology. I will just tell you 3 things. We have 3 projects. Actually, BHEL in 1997, they started working on coal gasification for IGCC power generation plants. So they had developed fluoride bed technology in their Trichy plant. What we had thought that technology will be suited for the high ash coal. So one project in Mahanadi Coalfield Limited, in which I am MD of BCGCL, we are taking the help of BHEL, and we are thinking about setting up this project, which will be first of its kind in India, which will be developed on the Indian technology. So this technology will be upscaled. They had produced syngas with 180 ton per day of coal feed, and that ash was more than 35%. So now we are giving wash coal to this plant at Lakhanpur. We have floated the tender, and likely by 7th of July, all the tenders bids will be submitted for the major tenders. Prospective bidders like L&T, L&T, Toyo, and Technimont, they will be submitting the bids by 7th of July. And we are hopeful that the DPR will be prepared by September, so that this first project on gasification can come up on BHEL technology. Now the second, which the problem is coming with the technology in which GAIL and Coal India has joined hand together. We had floated a tender, EOI, for shortlisting of gasification licenser. Hope I'm connected now. Means I'm not getting.
Yes, sir. You are there. You are audible.
Yeah, okay. So for this, actually, we had in talk with some Chinese operators also, those who have running gasifier. They have provided technology to running gasifiers for more than 100 gasifiers running in China. The challenge is that either we have to wash our coal of Sonpur Bajari, which is at 24% ash, because none of the end user is ready to give a certificate that they are running a gasifier with 24% ash. So now we are now also negotiating with them. We are coming up with this, but definitely we want that a gasifier, rather than spending 13,000 crore rupees on a project, we should be certain that the money is not going into drain. There should be some proof that the technology is running somewhere on suitable ash content of coal. We are also thinking about pilot scale of operations. We are in talk with some of the gasification licenses in US, some in Japan, and even we will discuss with Thermax also, who are planning to develop, and they have developed about 6 tons per day, something like capacity. So we can upscale is 200 tons per day. So there will be two-way approach. One is commercial plant and one will be on pilot project. So we'll be definitely supporting the Indian technology developers to have a demonstration scale project. And also by the time, if any technology we are shortlisting from China or from any other part of the world, we will take up those projects also. So yeah, I'm here open to suggestions, any questions you are. If I will get time after 4 p.m. again, I will join back. I will just check from the question answer chat box. There is no question. So
just one question. I think it's a question. One of the question is there in the question box, but that is addressed to Vaidya. But as a follow-up question, I would just like to ask one more. Is there a carbon capture program also being followed in this HPCL coal venture?
see, I will tell you in a very light mode. It cannot be quoted much.
Okay.
Okay, for oil and gas, so much of profit has been made that Dubai was constructed. And even they could not do CCUS till date. So see, I will say that coal gasification is a baby. Let us not put all the load on coal gasification to develop CCUS technology.
Okay.
But one thing I will say that in carbon, because there is no need to capture, in coal gasification we get 100% CO2. We are ready to supply 100% CO2 to anybody, but developing the technology from coal gasification operators will be injustice to us.
I agree with you. It's a valid point, and I would appreciate the effort that has gone into this venture, wherein complete indigenous technology, one which has been developed by BHEL and also later on developed along with Thermax, is getting an opportunity to be implemented at commercial scale. And we are looking forward to your tender process being complete, leading to a subsequent award of jobs and contracts, which will see the movement on this project materializing. So thank you very much, Dr. Sir. In case you are back and we have some more questions in the question and answer box for you, we'll put them across to you when you're back with us. So thank you very much for your presence and your sharing of your initiative and the efforts that are going into this new venture that you are heading as a managing director. Thank you very much.
Thank you, sir. Actually, right now, after 3 hours, we have a meeting on post-award consultancy.
Okay.
We are again going to engage somebody. We are expecting that by October, we should start this project.
Okay.
So
Very good. Great.
Thank you.
Thank you, Piyush.
Thank you.
Thank you. We go to the second speaker, Mr. Manish Shandilia. Mr. Manish is Chief General Manager in the Process Design and Development Department of EIL, has over 30 years of experience in doing feasibility studies, technical due diligence, licenses selection, the formal basic engineering design package preparation, which is the bread and butter of the process engineer in EIL, the detail engineering and troubleshooting on all projects that are taken up by EIL. And he is involved in greenfield, brownfield, and revamp units and complexes, both in the refining and downstream. And his topic for today is the new concepts of refinery and petrochemical integration. We have been exposed to the conventional concepts wherein FCC cracker gets integrated along with the DFCU, dual fuel cracker unit. But let's hear from Mr. Manish what are the new concepts that he would like to put before us for the refinery petrochemical integration for the coming years. Over to you, Manish.
Thank you, sir. Thank you for the nice introduction. Thank you, LKMT, for inviting EIL and giving me this opportunity. I would like to share my slide, please. So is it?
You can see that.
Okay. Okay. So my topic is the new and emerging refinery petrochemical complex integration. The topic, I will try to cover this in four basic. Am I audible, sir?
You're audible, but can you put your slides in the slide mode?
Yeah, I'm trying to do that only, sir. 1 second, please.
Okay.
Why is it not happening?
It's not happening. Okay. No. Then we can continue in this because as long as the font is large, you are able to read it. So let's go ahead. Let's see how we. Yeah, that's better.
So where is the slide now? Okay, so I have divided the presentation in 4 blocks. A very quick background of my company, the future outlook and the drivers for the refinery and petrochemical integration, an overview of how we go about doing this integration in the projects that we have set up or are in the process of the study, and some of our experiences thus far with the industry. So most of the people would be, sorry, still I'm not able to show in the slideshow, but EIL is a global engineering consultancy, project management and total solutions company. It's a wholly owned company under the aegis of Ministry of MOPNG. We've had about 7,000 assignments done so far, and we have had a significant track record in the entire oil and gas value chain. We have about in-house technologies, about 40 technologies, and we have international presence in Middle East, South Asia, Central Asia, Mongolia, South America. We have about 2,700 employees, and we are diversified into infrastructure, strategic crude oil storage, fertilizer, ports, LNG, water and waste management, coal gasification, ferrous and non-ferrous, renewables and clean energy. EIL is also addressing the sunrise sectors of biofuels, green hydrogen, ammonia, and energy transition. So why a very brief perspective of the need for petrochemicals and refinery to come together. Historically, the demand in petrochemicals in India for the year 2020 is about 27 MMTPA. We still are doing about 1/3 of global average, which for us is about 12 kg. We still have a substantial transportation fuel demand, and we expect this petrochemical demand to nearly jump up from 27 to about 87 plus or 85 plus in the year 2040, and for which capacity additions have been planned, are underway or under study for domestic and export demands, as well as for using the integrated refinery petrochemical complex. The shift is towards a deeper processing of crude oil, and there are various disruptions which are being considered are part of our studies when we look towards a sustainable future. as per the knowledge available with us right now, can you see that today we are almost at 250 million tons of crude throughput, and by year 2030 expected to about 310, and there are projections of about 2040 to about 400 MMTPA. And now, as the people in the industry are very well aware that besides the fuels, to make the refinery and the crude oil profitable, it needs an integration, or some petrochemical products have to come out because of the differential of the price. So historically, the refineries were driven by very earlier on by kerosene and fuels. Environmental aspects were always there. The crude prices were high. They are still so. There was a crude flexibility to be built in, and bottom of barrel by the methods of coker, and before that visbreaker was being addressed. Now, as things have moved ahead, we are looking for we have moved away from visbreaker to delayed coker, two delayed cokers, petcoke going to the CFBC, then the delayed coker bottoms being connected to petchem to petcoke gasification. Now we are looking for vacuum residue hydroprocessing, and so that we can go as low as converting about to the maximum of nearly 10% of the bottoms, or integrating it with the coker and then still bringing it down to 10%. So these drivers are now the refiners nowadays and also in the coming are targeting to eliminate high sulfur fuel oil. There are environmental concerns which is forcing the petcoke disposal options. There is an increase in petrochemical demand, and so I was this slide, and then again the prerequisite of high crude, the consideration of high crude prices and crude flexibility is still there. So the expected drivers now, whenever we are configuring now, are the environmental changes that are getting imposed, the product demand is altering, and there is a huge requirement of digitalization. The digitalization which is being built in right now are using the basically real-time optimization, intelligent data processing, asset integrity management, and increased safety. So there is an increased incorporation of the AI and ML models. The projects that we are executing right now have a demand coming in from the client, and these are being done. There is an integration of instruments which leads to the collecting and processing of video, audio, and biometric data. And there is a built-in of predictive and preventive maintenance. So these are the things which we take care while we are configuring the current refineries. Looking ahead in the future, the refinery, increasingly the refiners are asking for utilization of green hydrogen, for carbon capture, for considering plastics into fuel oil, as a feedstock, recycling, definitely integration of oil refining, and also the need of integrating biorefineries and utilization of the renewable power. This is helping people the refiners to basically, besides being integrated with the chemicals, to become smarter, efficient, connected, more reliable, and which brings better margins to them and increase sustainability. Now, up till now, in most of the companies were focusing on the bulks. Interest is being shown by the refiners to accommodate niche petrochemical production right now, right away in the initial configurations, and the niche petrochemical production is bringing in the challenge of emergence of customized business models to deal with the technology availability in sourcing. Not all technology suppliers who are in this business are willing to be a licensor. They want to be a participant along with be a part owner in one way or the other. And that is something which the refiners and the operators are increasingly finding to deal with. Some of the refiners have already successfully incorporated these, and the new refiners are considering developing and making the systems in their organization to work with these environments. Now, the levels of integration traditionally have been starting from fuel refineries, have been using a FCC to prepare propylene, which was basically 5 to 6% kind of petrochemical intensity. It moved to creation of, there was integration of aromatics, incorporation of steam cracker, The capacities were earlier on 700, 800 KTPAs. Now, by the place further, as you go up the pyramid, there has been utilization of bottoms hydroprocessing as well as bigger steam cracker capacities, higher yields of the propylene from the FCCs, the valorization of ethylene from FCCs, which is bringing up the petrochemical intensities from a low value of about 4 to 5% to in the realm of 20 to 30. These are the complexes which are either operating or under execution. And the next look ahead is to target more than 30%. There are operators who are interested in going up to 50%. There are operators who are considering targeting as high as 70%, but those are the disruptive technologies which are under the various, I would say, the stages of commercialization. But going to technologies of 50%, it is possible, which is definitely possible, which requires a combination and placement of various factors which enable that. So, in brief, the projects which we have implemented or under as EIL for the petrochemical intensities are right up to 20%. They are already operating. More than 20 to 30%, they are under construction. The concept studies are going to 50%, and depending upon the objectives, we have tried to hit beyond 50 also. The intensity would depend upon the choice of the petrochemical that is considered. For example, PX-PTA. Other chemicals could be PVC, ethylene oxide, propylene oxides, which could also help in increasing the intensity to beyond fuels, much higher than in the realm of 50%. So the way we go about doing it is utilizing thus far proven commercial technologies, optimizing the molecule management, minimizing the fuels, and however still keeping the flexibility between petrochemicals and fuels, because there would be scenarios of shutdown where the complexes would not like to shut down, or there will be downturns in the commercial cycles which would need. And this requires the balancing of the capex, water management, power, hydrogen, carbon emissions, and the solid and liquid effluent generation. All of this traditionally has been going on, but building the petrochemical, once you integrate this, the capex rises substantially, which has to be very effectively managed to stay profitable by employing and capturing or allocating the molecules properly. So then there are two ways one can approach about it. One is integrating it into an existing refinery or building up the refinery and petrochemical complex together. The moment one brings in the integration to an already standing refinery, there would be challenges which would be the processing of low carbon intensity residues. There would be integration of HGU and FCC. There are needs of converting the hydrogen gets, as cracker is a big creator of hydrogen. So there would be a hydrogen level integration, plastics to oil recycling, electrification of drives. Right now, there are contemplation of electrification of furnaces, though still on a demo stage. And there is going to be a substantial impact on the utility system design, because the need of especially the nitrogen, the cooling water, and the power increases substantially the moment one moves from the refinery into petrochemical. Similarly, opportunities exist of using low carbon intensity biofuels like ethanol and SAF to increase the profitability of the complex. So this needs to be known upfront and decided right at the configuration stage itself. So the feedstock options that get explored when we are talking about this integration are, for example, starting with crude oil. So the light sweet crudes are preferred. However, the heavy sour and light crude differential has to be built in for the economics. Condensates also, however, they do not bring the heavy ends, so the capex gets optimized, but the challenge comes from a sustained supply of condensates. LPG and C3, C4 would be the most preferred feedstock. However, again, it's the availability of these feedstocks which is a challenge. and hence the balancing of the P/E ratio in the cracker and the FCC has to be managed, because very rarely will it be possible to have a light cracker. More often than not, when we are integrating, we will be bringing in heavy streams like kero and diesel. So the design of the furnaces and the choosing the right P/E ratio becomes important. Interests have been shown by operators to bring in ethane directly, which gives the highest ethylene yield. But again, the consideration of the supply and logistics and the operation of the cracker, though become simpler, but yes, this kind of cracker does require a higher utility as compared to other crackers. The fourth option, which is the rich gas from the LNG, there are already crackers operating in the country. This requires again the sourcing chain. So basically the message here is that the feed to the refinery starts changing. However, the refinery also has to satisfy its primary requirement of maintaining and servicing the fuel's demand. So that's a challenge wherein the design of the complex needs to have a wide spectrum, so that it can take care of the market economics while keeping itself profitable. So the proven there has been interest into the straight conversion of crude into chemicals. This technology is primarily right now under development stage, though some projects worldwide have gone, but still it is still under. Not many people have still used it. The proven technologies come up with less risk. It can handle varied crude slates. It's easier to source, and it can be integrated. However, there is a lot of interest in integrated crude to chemicals because it brings with it a much higher petrochemical intensity. So, for example, this is a very high level template of what needs to be there in an operator's mind, what bullet points have to be there. For example, the first thing, as obvious, is to set up an integrated refinery cum petrochemical complex, or to put a chemical complex onto a crude oil complex. Then the crude throughput and quality needs to be iterated, and the diet has to be established. If there is any other feed streams, opportunity feed stream, for example, naphtha or LPG or ethane, if the refiner can or the operator can source. The products desired, the primary being ethylene, propylene, monomer. Are there any specialty petchems in the horizon? Whether PTA, PX is a thought process, and one very important thing would be what kind of fuels the refiner would like to service as a base demand. The location becomes extremely important. We have the experiences that we have seen the operators moving from various locations, not just from the fiscal incentives, but also to make the logistics of incomings and the outgoings favorable to the complex. Then comes the stages that it has to go through. Typically, it goes through a pre-feasibility stage. The capex estimate that we have seen at this level could be as better as the 30%. Some people have also opted for close to 50% to go for a pre-feasibility. Then moving into a DFS, which has been done with technology selection or without also. This again depends upon what is their need. We have handled 20%, 30% accuracies. The execution mode, because of the multiplicity of the units, multiplicity of the licensors, and the multiplicity of the business model of getting the licenses onboarded or the technology supplier onboarded, makes it very important that the execution mode is very well understood. Most of the time, it requires a hybrid mode, which would be a amalgamation of EPC, EPCM, the JV route. So, which brings its own commercial challenges because of the amount of the capex involved and because of the needs and the way the niche petrochemical operators operate. And then leading up to the feed preparation, which would also bring with itself a higher capex estimation accuracy, close to about 10%. So these are the things which have to be in the drawing board, and all these things go hand in glove, keep iterating till the time we move at least to the technology selection stage. So thus far, a brief overview of the experiences that EIL has got. We have set up already an operational petrochemical complex of refinery cum petrochemical complex, which had a subsequent integration into the refinery, having a steam cracker of 1200. Mostly they were the bulk petrochemicals near to about 20% intensity. This was done on an EPCM PMC route and done in different phases. This is successfully operating. There's another complex in central India, again, wherein there is an integration of the petrochemical into a refinery. Again, bulks, right now with a petrochemical intensity of close to 20%. Before that, it was nearly zero. Then there's a well aware of the petrochemical complex in the west of India that has been raised to 25% with a steam cracker of 1000. Here, the FCC and the steam cracker has been integrated with the C2, C3 valorization, still focused on the bulks. And a complex in the South India, wherein the cat cracker was taken to the cat cracker C3s was which traditionally goes to PP, has been taken to petrochemical derivatives like oxo alcohols and acrylates. And right now, so these are the projects which has been like sub 25% or 20 to 25% numbers. EIL is presently engaged in doing studies which are greater than 30%, which as well as hitting above 50%. These are on the various feasibility levels right now, but and these have been done with these are being done with conventional technologies and employing the bulks and the specialty as well as niche derivatives. So these are the studies which are right now. These are only at the study stage. Maybe some of them are at PFR, some of them are at DFR, and some of them have progressed to technology selection. So in a year or so, probably we'll be talking about BDEPs in few of them. So from my side, this is what I wanted to present to the esteemed gathering here. Thank you.
Thank you. Thank you, Manish. That was a quick overview of what all refinery integration has been done along with petrochemicals in the last couple of years by EIL. And I'm sure that in the coming years, you will have many more opportunities and different configuration to also quote. But to date, the integration that EIL has done for BPCL Kochi, which is through the propylene derivative complex, where you have a much wider range of petrochemicals and a different range of petrochemicals to have
Yes, sir. Yes, sir.
produced. That remains one of the most unique projects to have been handled.
Yes, sir.
Something different than the normal conventional ethylene propylene and polyethylene polypropylene integration.
Yes, sir.
Something different on this project. In case you have time, Manish, just quickly go through some of the questions that
Yes, sir.
you may have. And if you can try to answer them in the box itself, it's good. Otherwise, when we take up the final round of question answers towards the end of all the presentations, you could probably answer during that time as well. So just have a look at the presentation. Now we go to the next speaker, Mr. Rajiv Narang. Mr. Rajiv Narang is working as Executive Director and Global Head of the Process Economics Program at S&P Global. Has over 35 years experience with various energy companies and consultancies like Bechtel, Fluor, Petrofac, and also PSUs like ONGC and GAIL. So that's a wide range of experience that Rajiv has. And he's bringing all of them into play when he oversees technology reviews. So when I decided to invite Rajiv, I was very conscious of the fact that he is not into developing of technology himself, but he is definitely evaluating those very closely, not only from the point of view of their technical feasibility, but also their financial viability. So I thought he was a very important person and a speaker to be had on this webinar. He's a member of the American Institute of Chemical Engineers and a chartered engineer in the UK, as well as a fellow of the Institute of Chemical Engineers in UK. He's also an MBA degree holder, apart from his graduation from IIT Delhi. So over to you, Rajiv, for your presentation on the topic of disruptive technologies and public policy. Over to you.
Thank you. Thank you, Ajay, for the kind words and the kind introduction. I will be sharing my screen. Just a second. Give me. Okay. Can we see the screen? as yet?
Not yet.
Not yet. Okay, hang on. Share. Okay, maybe this one will work now.
Yes, it's okay now.
Yes. Okay, now. Okay, let me put it in
The slide mode.
a slide mode. And I beg everybody's forgiveness. I am in London, and you can probably not see the London skyline behind me, but it's a hotel, so I'm cramped. I'm cramped for style and time and place. So please forgive me. Okay,
Rajiv, before you start, just let me put in a word of expectation from my side.
okay.
I'm sure you will be talking about the success stories that are there in your process economic programs, the ones which are technically proving themselves and also financially proving to be viable. They will definitely be covered in your presentation. But I would like to, rather, we would also like to know that those who don't make this cut, those who don't
Right.
make cut, what is their future, and how do you take care of that? Or is there any way in which you can support, or you tend to support them, or is there any way that they can see the light of the day as well?
Okay. Thank you, Ajay. I think you have a copy of the presentation. So I will be talking about some technologies which are really interesting. We have seen them fly past our drawing board and find them interesting. But another interesting bit I would like to tell is PEP typically keeps a voting program amongst all our major clients. So we don't decide what to do. It's our clients and subscribers who decide that this is important, and they decide for us.
Okay.
And so typically the world's major operators decide what we should do. So we are colored in that way that
Right.
we can't do really cutting edge stuff because we are limited by what we can do. But we have a small narrow window of trying to do things we think are important, which may not be commercially out there, but are important.
Okay.
A word from our sponsors, PEP. I work for PEP, and recently we have covered some of the sustainable technologies you can see on the screen. But what's interesting is PEP is more than 60 years, 63 years old. It started off in 63 and it's 60 plus years old now. And it has got over 2,100 processes in its inventory. So that's always interesting too. Okay, this is, I'm going to minimize my screen. I have a small screen. So Ajay, please, flag it up if something goes wrong.
Okay.
The Okay, so this is the decarbonization map which our in-house team has put together over a couple of years, more than a couple of years, and we can see the overall paths which many of our clients have taken. Uh, I will be talking about three of these which we think are technologies which can disrupt the market or which can then become a leading technology which can be adopted by many people. Uh, and the ones are highlighted in yellow. SMR, small modular reactors, in carbon capture mineralization, and this is not really disruptive efficiency of a particular plant, and why we should be looking this as a low hanging fruit. Now this is not really disruptive, but I think it's important from the point of view of public policy. uh, but every technology in this in the various boxes are important. The big message is there is no one silver bullet to decarbonize a plant. We need a plethora of these technologies uh, and first I'm going to talk about a paradigm shift which I think the industry is slowly coming to terms with. And the paradigm is that the highest form of energy is work and electricity. I mean, this is college stuff. Thermal energy is a low form. Thermal to work conversion is 30% current efficiency. And that means electricity is the most expensive energy. This is the paradigm. And the shift which needs to happen is because of renewable electricity. Renewable electricity is claimed to be plentiful and cheap. And that's the paradigm shift which needs, a, a closer look. Instead of being the most expensive energy, it is nowadays the first go-to energy source for any new modern plant. And the second paradigm shift is high temperature thermal is hard to abate. Uh, and we can see that in cokers, in crackers, in hydrogen reformers. Uh, it is what is stopping us is actually the high temperature thermal heat. The electricity has still not made its way out there, but it is trying to. And here is an example. Electrification of crackers is under development, is what we have found out. And the people who are working in this field are given on the right-hand side: Linde, Sheldau, Technip. And the most interesting to us is the Colebrook rotating cracker, rotodynamic reactor technology, which is in pilot scale. But what I would like to point out here in all this is, if you look at the electric furnaces, that's about half a gigawatt, more than half, so 600 megawatt. And we still have to do some fuel firing of 74 megawatts. And all this is renewable electricity. For a typical, this is for a 1 million TPA ethylene plant. For a 1.5 million TPA ethylene plant, typically you need a gigawatt of electricity, which has to be renewable and has to be robust 24/7. And that, I think, is a big challenge sitting with us. So talking about efficiency, the first technology, and I'm cheating out here. I'm really not, it's not really disruptive. But I think it needs help, and it works together with renewable electricity, which is claimed to be plentiful and cheap. Why would anyone spend money to change a compressor? A typical highest consuming machinery, rotating machinery in a plant is a compressor. It runs in megawatts mostly, pumps probably in kilowatts. And why would I want to change a compressor from, say, steam running today to a variable speed electrical with a very high efficiency? And the only way I can do this is if somebody puts a carbon price on it. The price of carbon has yet not been put in many countries, except maybe in Europe, where we have a carbon trading scheme, and maybe South Korea. So that's one point. If we put a carbon price on the CO2, or we legislate it like we did for sulfur. We just legislated it and said not more than 10 ppm in gasoline, and that's it. So anything else can be gamed. And this is what we have observed. There's a lot of subsidy harvesting which is happening all over the world. There is no forcing the issue either from the public policy or from the legislatures. Subsidies, yes. Carbon trading, yes, it can happen. But really, we need to force the issue now to make even a simple thing like efficiency viable. The second one I want to put on is a small modular reactor. This is the nuclear reactors, not chemical reactors. And they are manufactured in fab shops, and they overcome some of the disadvantages of large gigawatt kind of reactors like Vogtle AP1000, which was delayed by many years, and the cost, and you can see the cost went up by almost 3 or 4 times. SMRs, multiple modules can be installed to increase the output. The low thermal power of a module enables the passive safety features. This is the most important thing, because they are inherently safer. When they can look after themselves, they are walk-away safe. One of the big critics of nuclear is actually the safety angle, and justifiably so. So SMR counters that to a very large extent. Of course, you can couple an SMR with steam as heating medium or as a cogeneration plant, and it is very, very useful where we want to link it up with the grid, which cannot absorb a gigawatt scale plant. That's another thing. The policies of most companies say that one single source cannot be more than 20 or 30% of the local grid. So a large nuclear plant has difficulty in hooking up to that grid. There are the following technologies by IEA, acknowledged by IEA, the water-cooled one, which is the most common technology even in the large reactors. The high temperature gas cooled, that's very interesting, and in the next slide I'll show you why. The fast neutron spectrum, the molten salt is also very interesting, and then they are lab scale micro reactors. And here's the difference. PWR is pressurized water reactor, boiling water reactor at BWR, high temperature gas reactor, and the sodium fast reactor. And I would like you to keep an eye on the last row, the secondary coolant. This is the heat we are extracting from the reactor. And as you can see, the pressurized water reactor, the most common reactor, has got a temperature limit of about less than 300 degrees centigrade, which means it cannot satisfy the high temperature thermal heat of most process plants. And we see the high temperature gas reactor, we can go up to 700 degrees centigrade, now starts coming close to what the high temperature furnaces demand can give. I think Microsoft X Energy, Dow X Energy, sorry, and Microsoft has gone for sodium fast reactor, but Dow X Energy are going in for high temperature gas reactor, while most are going in for pressurized water reactor. And here is a pressurized water reactor, which is new scale. And then you can see it's a 77 megawatt electrical. You can hook up to 12 of them to make it 924 megawatts. Here is a challenge. 60 years is a challenge. Most plants which we design in chemical industry are about 20. They'll run for 30 years, and then they start technology starts overcoming them. So, but this one is designed for 60 years, so it can probably run more than that. And it's walkaway safe, and more important, you can set it up right next to the plant and not in some remote area. That's the patent for new scale in power module. But what is the support it needs? Regulatory clearances. We have to crash the process of getting SMRs built right next to a refinery or a petrochemical plant. Safer designs need public buy-in. We need good PR. We need private players and government working in tandem. Fuel supply in our book should not be a problem. Is traditional fuel supply, unless it is the newfound gas-heated reactors where one really needs a special design for the fuels. And the last one, liability limitations. This has been a thing of contention between private players and the governments, where we want to reduce the risk to private players. And this is important in another sense. If you look at history, shale gas was not invented, or not invented is the wrong word, was not discovered by big players. It was like small backyard players who actually discovered shale gas, which means in a country like US, where entrepreneurship is respected and protected to an extent, they could do it. We need a similar unshackling of entrepreneurship in India. After all, it is a lot of Indian people and Indian engineers who go to US and are a big success, but not in India. And one of the reasons we think, or at least I think, is that we are not able to give them a secure environment with liability protection in case something goes wrong. So risk taking is very, very low. And we heard that, we want big companies to take on technologies which are proven. That's not going to happen with the newer technologies. The next thing I'm going to talk about is mineralization. And why? Carbon capture is a proven technique. It's akin to natural gas processing. We know it. We use it in every refinery. In fact, we do not capture, but we do extract H2S and CO2 from our streams, refinery streams. But the biggest hindrance with carbon capture is actually the regeneration energy needed. For a coal-fired plant, it can increase the cost of your electricity by over 50%. Mineralization allows direct sequestration of CO2 in rocks, thereby avoiding the regeneration penalty. So you need not regenerate the rock. Once it grabs into the rock, that's it. You need not close the cycle. Of course, you have to do some preparation for the rocks to speed up the kinetics of mineralization, but you don't have to recycle the entire sequestration or the capture stream. And India has one of the biggest sinks of basalt in the Deccan Plateau. And here is a map of basalt and other CO2 sequestration. And you can see in this region we have, and in this region we have a large potential for straight away putting CO2 into basalt and straight away mineralization, mineralizing it for thousands of years. So this is something, an advantage which India has, and that's another thing we really need our governments and our policy people to help leverage mineralization by telling us who owns the pore space. In US, the pore space is owned by the person who owns the surface, not in India. India, anything below the surface still belongs to the government, which then starts becoming an issue when you want to license it. Again, liability limitation, we have to work with that. Once you have sequestered the CO2, the private players need some kind of protection as to liability limitation in case something goes wrong, the CO2 comes out. Research, yes, we need a proof of concept, but I think IIT Bombay is already well on its way to that, and then that's a plus point. But again, we need to give private operators easy entry, which means we need to put a price on the carbon. Why would anybody put CO2 which is not producing anything of economic value to the society? Why would we do that? Why would anybody do that? And the reason is because we can then if we put a price on CO2 and say, hey, I'm going to pay you this much because then I'm going to load my main product, whatever I'm making, some plastics or something, with the carbon price which I'm going to pay you, then it's going to work. But unless that full chain is closed, this is not going to happen. So that's where policy comes in. There are some other disruptive technologies. Well, I talked about 3, but there are some other ones which have crossed our drawing board. One is direct air capture. And I see when all else fails, DAC will save the day. This is my favorite saying. I've been saying it everywhere. The advantage with DAC is, direct air capture, is that everywhere it is the same feedstock and it is clean and pure. Air has got 400 ppm CO2. It's clean and pure everywhere in the world. So I'm not limited by putting up a plant next to a flue gas stack. The other one which we think is important are sorbents regenerating at less than 100 degrees centigrade. And then we have been coming across that that there are sorbents less than 100 degrees centigrade, but you got to be careful on what it will cost you. And finally, process intensification. And we congratulate HPCL. They've already implemented it. And while I'm in London, I'm actually talking to Carbon Clean tomorrow. I'm going meeting them and seeing their in their head office out here, and to see what they have to offer. Similarly, how I'm also talking to HPCL. Finally, CSP. CSP is, to my mind, one of the good solutions. Concentrated solar power, which can reach the temperatures we want. and that can overcome intermittency. I've put pumped hydropower, but CSP can also work with molten salts, like nuclear, with molten salts to give you power and electricity when the wind doesn't blow and the sun doesn't shine. And finally, I missed out the first one, hydrogen. White hydrogen, which is hydrogen which can extract from underground, like we do oil and gas, and that we are watching the space. It is there. I know of at least 2 companies who are looking at it and who have come to us and asked us, once we have extracted it, what do we do with it? How do we transport the hydrogen? So there are challenges to that. The first one is, of course, extracting the white hydrogen. And this is my last slide, and this sort of addresses some of the queries, Ajay, you had. This is another paradigm shift I always talk about, and the paradigm is bigger is better, economies of scale, and world scale capacity. So this is the paradigm we have. The bigger we build them, the better it is. But I would like to put a shift to that. I say smaller is smarter. And one of the reasons is that plastics recycling and biomass processing are inherently limited by collection. How can you collect it and make it of the requisite quality? And we heard Mr. Vaidya talk about it. How can we for MSW gasification? How can we meet the criteria for making these waste products? These are all wastes, the societal wastes, to make them uh, fit enough to be processed in, let's say, plasma gasification or anything else. Similarly with MSW. And this is where I think the engineers and the policy makers' gaze needs to change, which is uh, make things smarter. We are limited by the amount of quantity we have. We can't look from 30,000 feet to 100 feet perspective. A bigger plant, if you take a big 1 million ton per annum plant and say, I'm going to make 1,000 ton per annum plant, from that gaze, from that perspective, it's never going to work. We have to start working from the bottom, saying, this is what we have. This is the feedstock we have. This is the contaminants it has. What can we do with it? And here is where both the engineers and the policymakers' gaze needs to change. And finally, my last message, there is no such thing as free decarbonization. Society needs to pay the green premium, and there is no soft way of saying this. There is no easy way of saying this. How much it needs to pay, that's where engineers and policymakers come in. We can look at technologies which minimize this pain, or as I call the path of least regrets. We can go down that path and we can first identify that path. And with that, I would like to finish my talk by asking for a call for registering for APAC 2025 in Singapore. Whoever wants to come in, please do. There will be very interesting folks out there you can talk to. With that, let me stop sharing my screen and go back to you, Ajay.
Thank you, Rajiv. It was a nice presentation, very different focus than what you normally put into your PAP
Yes,
posts about conventional chemical processes, conventional chemical products. Your emphasis in this presentation was very different. And I'm glad that when you were different today and your focus was different today. It was definitely more about the future rather than what we all are currently up to. We talked about 20, 25 years life, and you talked about things which are demanding 60 years of design life in their design. So, and SMR is a in thing. I think it's been taken up at the highest level of the government. How SMRs can be put into more use so that we are having more increasing self-sufficiency with renewable power rather than conventional power.
Yeah.
And many, yeah.
Yeah, if I may,
Sure.
if I may come in, there is a merger of SMR and a petrochemical plant. We can put a small SMR right on the boundary of a big petrochemical plant. 77 megawatt is the smallest you can put in.
Okay.
Let's, we should really be thinking about that proven technology, and at least the electricity can be decarbonized, and you can also decarbonize some thermal heat. It is giving 300 degrees centigrade. We can transport that thermal heat into the plant and decarbonize at least some part of the thermal heat.
So what you're saying is, apart from the simple transfer of power or electrical power, you could have transfer or cross flow of hot streams also.
Hot streams.
Hot
Yes.
streams also.
And we wrote a white paper on it last year. I'll be happy to share it with you, Ajay, in
Okay.
which we have run the numbers of a
Okay.
integrated petrochemical plant and
Okay.
an SMR. We run the numbers and we have figured out how much you can decarbonize. And I'll be happy to share that white
Okay.
paper.
And this was done at the behest of some client who wanted a petrochemical.
No, it was done at the behest of my vice president, who said, I'm confused by all this people talking SMR, Dow talking SMR. Tell me what it is. So we said, okay, let's get our teeth into it.
My interest was mainly from this point of view, that who shows the interest first, the SMR lobby or the petrochemical lobby? Ultimately, both of them stand to gain. But then
Yes.
who takes the first step of commissioning a study and probably making payment towards that study to get
SMR.
the
SMRP. SMRP.
Thank you. Thank you.
Thank you.
I know our conversation can go very long,
I know.
Rajiv,
So
because you
let's
have
stop.
always so much to share. But then let's look at the two speakers who are waiting in the wings. And
Yes,
at the
yes.
end of all the presentations, I request you to have a look at some of the questions that might have come your way. You can select some of them or give a common answer to all of them at the end of it when we have the final session of the question and answers. So now we go over to Dr. Maitra. Dr. Partha Maitra is actually a name so very well known in all energy sector programs, be it the physical seminars or the electronic online webinars. He is omnipresent. If there is a presentation on energy, refining, petrochemical, Dr. Maitra has to be there. And it's what he is going to present today, because he shared the copy of the presentation with us ahead of the program, is in a sense what I was looking for as a content of this program. We are having many webinars and seminars which are covering new concepts, renewable energy, biofuels, climate change, etc., etc. New developments happening in these spheres are what is probably hydrogen, of course, is one of them. Green hydrogen is being discussed left and right almost in every program. But what we were not getting to know is the conventional industry, be it the conventional refining and petrochemical industry, oil and gas industry, or maybe the coal gasification or coal monetization industry. This conventional industry, what are their strategies and efforts towards towards climate change or energy transition or reduction of emissions? So when I saw the presentation of Dr. Maitra, I exactly found out what I wanted this program to cover. So I will not elaborate more. I will just hand it over to Dr. Maitra after a brief introduction. Firstly, it doesn't need an introduction, but nevertheless, let me read out his credentials. He was responsible for conceptualization and optimization of the iconic Jamnagar super site with the complex refinery, petrochemical, and gasification integration. I think this statement says it all. That's what all he does for his employer, that is Reliance. His strategy and mandate is to decarbonize and convert Jamnagar refinery to a COTC, that is crude oil to chemicals venture. He has worked on energy conservation and refinery modernization and resid upgradation projects in many US refineries before he came to India and joined Reliance. He is a PhD in chemical engineering from University of Houston, and is a graduate of IIT Bombay. So, Dr. Maitra, over to you.
Thank you very much. Thank you for those very kind words and introduction. Can I see the first slide,
Yes.
please?
Yes.
Yeah, so this is, we are talking of future of olefins, and there is a reason why we have selected olefins, because olefins is the #1 petrochemical in the world. So if we can figure out what happens to olefins, we can figure out what happens to other chemicals as well. Second slide, next slide. This is, I am speaking not on behalf of Reliance, but in my personal capacity. So that's the disclaimer. Next slide. So my topic will first introduce why we are even talking about future of olefins. Next, we will talk about how do we go for low emission olefins. In that, we'll talk about electrification, feed optimization, and circular feed. Uh, we can do one or more, but basically these are the means to reduce the carbon intensity of olefins. And in future, we have to go towards zero emission olefins. And we'll talk about H cracker, E cracker, R cracker, and finally also EDH, which is ethane dehydrogenation. And finally, we'll draw some conclusions. But the most important point in this slide is, do not extrapolate the past or even the present to go to the future, because there is a disruption happening, especially in the domain of olefins. So what you did in the past will not be, and I repeat, will not be valid for the future. Next. So let's talk let's understand why we are talking on the future of olefins. Olefins is a major petrochemical intermediate. A number of petrochemical products are made from olefins. Ethylene is the #1 uh, chemical by volume, and if you combine ethylene and propylene, they are the biggest building blocks for the global petrochemical industry. The technology, I think every one of you know, is steam cracking. There are also some other technologies to make olefins. There is MTO, methane to olefins. There is PDH, which is propane dehydrogenation. And there is also FCC, mainly to make lots of propylene. But at the end of the day, the real workhorse is steam cracking. Now, why are we talking about future? Because steam cracking, unfortunately, have very high energy consumption. As a result, they have very high emissions, and they are not fit for net zero. So if the world is gradually moving towards net zero, today's steam cracker does not fit the bill. And hence, we require something else in order to get sustainable olefins. That's why I repeat, the past will not be the same as the future. So future, we have to minimize emissions. We can minimize either by mandate or by carbon price, but it doesn't matter. The future of mankind depends on reducing CO2 or GHG, greenhouse gas emission. We have to either modify existing crackers in order to reduce carbon intensity, and for new crackers, we have to go, or we have to select zero emission olefins which are fit for net zero. In other words, the olefins business, the olefins technology is absolutely ripe for disruptive technology innovation. Next slide, please. So, for existing crackers, we have to do electrification. And how do we do electrification? We have to source renewable power. And now, as it was mentioned earlier, renewable power is cheaper in some cases than fuel. And for the heater, that is the steam cracker heater, we have to do three things. We have to increase the air preheat or combustion air preheat. We need to minimize steam generation, which is conventionally done today. And we have to still maintain maximum heater efficiency. Now, if we don't produce steam because we are getting renewable power from outside, we have to eliminate steam turbine drives in the purification section of a steam cracker. And we need to convert all the drivers of even large compressors like charge gas compressor, propylene refrigeration compressor, ethylene refrigeration compressors to motors powered by renewable power. We also have to focus on the transfer line exchangers, which today produces a lot of steam. Now we need to get into novel heat exchangers where the heat transfer is done by impingement, and we can do feed effluent heat exchangers. That means as we cool down the steam cracker heater effluent, we can heat up the feed and just do the top up heating in the steam cracker heater. We should only produce dilution steam in the transfer line exchangers. And the reason this exchanger has to be a little special, because we cannot have high residence time, because olefins, even when it is diluted with steam, tends to recombine, and the more the time we give, it recombines more. And hence, we have to have a quick heat exchange, not by quenching with water to produce steam, but with feed effluent heat exchangers. So that is item number one, electrification. Item number two is, next slide, feed optimization. Now, today, in India, it is extremely common. You want olefins, put up a naphtha cracker. I think we should re-evaluate that paradigm. The optimum feed is C2 and not naphtha. In fact, it is better to hydrocrack naphtha to C2 and C3 in order to optimize the feed, because I'm sure people will ask, oh, we don't have C2, what do we do? Now, we feed C2 in the stream cracker, we feed C3 in the PDH, because in the future, efficiency will become paramount, and whichever has the highest ethylene or propylene yields, they should be they should be used for future olefins. Now, actually, all refineries have C2 and C3, but unfortunately, I mean, most refineries, they do not have a refinery off-gas cracker. They do not recover the C2 and C3 and merrily burn it as a fuel. So, what I'm saying is, in future olefins, do not burn the existing C2 and C3 as fuels, but recover it as a prize, a feedstock for olefins. Naphtha, why is it a suboptimal feed? It is a suboptimal feed because it produces two products which are actually priced lower than the feed. It produces a high C1, that is methane, which is priced lower than naphtha, and it produces pi gas and pi oil, which are also heavy products, which are uh, very cyclic, and they are priced lower than feed. So it is, as I have told earlier, it is actually better to hydrocrack to C2 and C3. Of course, the hydrogen has to be sustainable or low carbon hydrogen. So cracker, if it is C2 feed, it has efficient carbon and hydrogen conversion, and the future belongs to high efficiency. It is streamlined cracking. In other words, it's a simple cracker, not with liquid feeds. We get what is known as competitive olefins, and most important, we will do optimal molecular management. So that is what is known as feed optimization. Next. So the other is the circular feed. Now, I think in this, people have said we have lots of biomass. We can produce fuels from the biomass, but the question is, why don't we produce some high value petrochemicals? Similarly, for waste plastic, pyrolysis also can lead to steam cracker feed. Now, there are some very interesting pyrolysis options which are available, especially for biomass or for waste plastic. And one of them in particular is supercritical water, which does not give tar in the pyrolysis. And it's worth looking at it if you want to have circular feed for your steam cracker. Similarly, some of the pyrolysis, biomass and others, give, instead of liquid products, they give gaseous products which can be directly integrated into the steam cracker as a steam cracker feed. Of course, we have the conventional way of biomass to ethanol, and the ethanol can be dehydrated to ethylene. Similarly, biomass can be converted to syngas or basically via alcohol to olefins. It can be via methanol to MQO. And if you have high carbon, low hydrogen syngas, you should even look at DME as an intermediate instead of methanol as an intermediate for future olefins. So, to summarize, we need to electrify, we need to have what are called optimum feed to the steam cracker, and third is it is helpful if we can get circular feed to the steam cracker. So these are for existing steam crackers. Let's go to new steam crackers. So, and this was mentioned again by previous speakers. So there are three ways to go for a new steam cracker. One is called the H cracker, where the low carbon hydrogen is used as a fuel for the cracker heater. How do we get this low carbon hydrogen? Now, if you have ethane as a feed to a steam cracker, the ethane produces C1 as a byproduct, and that C1 is sufficient via ATR or autothermal reforming and CCS, carbon capture and sequestration, to make hydrogen as a fuel for the steam cracker. Of course, it needs to be blue hydrogen. Now, this doesn't mean that we are done if we just switch the fuel from methane or C1 hydrogen. We still need to electrify, we still need to optimize the feed in order to eliminate the emissions. But a H cracker can be fit for a net zero. Now, Lummus and Dow are already working on the first commercial H cracker. That will be in Canada, in Fort Saskatchewan, and it will start up next year. So I think before India thinks about the next steam cracker, we should see how this H cracker pans out. Now, it's not a single horse race. Technip, LyondellBasell, that is LB, as well as Chevron Phillips, CP Chem, they are also in the race, though they are not as advanced as Lummus and Dow. So, H cracker can give you ultimate zero carbon fuel in order to get you future olefins. Next is e-cracker, and this is electric heating. So, the rationale for this cracker is, if we have to convert electricity to hydrogen and then use hydrogen, why not use electricity directly as a cracker heating medium? So it is electric heating. Now, there are two ways of e-cracker. The direct heating, where the coil, that is the pyrolysis coil within the steam cracker itself, it is metallic and it can act as a heating element. So you don't have to heat the whole heater, but you only have to heat the coil so that the feed in the coil, that is, can be steam cracked to olefins. The indirect is a very large toaster. Basically, you have coils in place of toast, and you have a heating element on both sides, and you heat up the coils uniformly so that it can crack crack into olefins. Now, the developer, it's by BASF plus SABIC and Linde. Now, they have named it as Star Bridge, and I think the name is very evocative, because they are, in order to heat up the e-heater or e-cracker, they use a star electrical connection, and they call it a bridge because it is a bridge between electrical energy and chemical energy or chemical synthesis, and hence it is Star Bridge. The demo, which used a full-size heater coil in late 2024, has been successful, and the first commercial plant, is being built by BASF in China. Now, again, it's going to start up after the Dow cracker, H cracker in Canada, but this should start up either end 2026 or definitely 2027. Let's call it 2027. So again, we have to see how it works out in practice. So again, message of caution, do not wait for this new next generation steam crackers for future olefins. Of course, e-cracker has to use renewable power. And as was mentioned by speakers before me, for a regular million tons ethylene, you require roughly 1 gigawatt of power. So it's a lot of power. Next slide, please. So this is the most disruptive innovation, and I would call it a R cracker or a rotary cracker. They rotate at high speed and convert, and in fact in supersonic speeds, and they convert the rotational energy to heat energy. They are known as rotodynamic reactor. So in the turbine, basically in a turbine, there are moving vanes which spins the gas at very, very high speeds. And interspersed with the moving vanes, there are the stationary vanes which suddenly stops the rotation and heats up the fluid. So there is a series of acceleration via rotation and followed by deceleration by stationary vanes. There are lots of stages. I mean, we are talking between 9 to 12 stages of acceleration to deceleration. And all of this happens by pulse heating with millisecond reaction. The total in all this rotodynamic reactor heating is less than 100 milliseconds, and it gives excellent, absolutely excellent olefin yields. The more important thing is, unlike the e-cracker, the 90% of the power in this case is converted to heat, thermal energy for cracking. So it has superior olefin yields, roughly 4 to 5%, better than conventional steam cracker for, let's say, C2 or naphtha cracking. Let's go to the next slide, please. So the developer is a Coolbrook consortium, which is in the Netherlands. Their pilot has been successful, again, spectacularly in 2024. The RDR, that is the rotating machinery, is supplied by ABB, former Asia Brown Boveri. So the advantage of this is superior yields, minimal coking, and simple maintenance. Actually, there is no coking within the rotating machinery, but all coking outside the RDR. So future, end of this year, they are working on the demo to convince people that it makes sense. And the first commercial will be end of 26 or beginning 27. So if you are looking for future olefins, you should definitely think about H cracker, about R cracker, and about E cracker. Next slide, please. Now, everyone asked the question that if we can do propane dehydrogenation, why can we not do ethane dehydrogenation? And because EDH will be similar to PDH. So I have good news for those people who are waiting anxiously for decades. We now have oxidative dehydrogenation. It is again by the same trio of BASF, SABIC, and Linde. It is at what is known as TRL9, that is waiting to be commercialized. So the two key elements of this process, the catalyst is a quaternary, that means 4 metal oxides, which is molybdenum, vanadium, titanium, and niobium, made by Clarion, which is a major catalyst supplier. The reactor is a multi-tube molten salt reactor, which is taken from maleic anhydride reactors, MA, and it is by a German company by MAN, a turbo, or MAN. And right now, the reactor, again based on maleic anhydride copy, it will be 250,000 tons of ethylene per reactor. And of course, you can do heat recovery. You can improve the efficiency in the molten salt reactor by either organic Rankine cycle, that is ORC, or via steam. The product is 82, because of oxidative, the product is 82% ethylene and 18% acetic acid. So if you are in the acetic acid business, it is it's a good deal. So that is another way for future olefins or future ethylene. This is only ethylene. Next slide, please. So this is the concluding slide. Steam cracker started its life in 1950s. For 70 years, it has got a spectacular success, but unfortunately, it is not sustainable for the future. For existing steam crackers, we need to reduce emissions either by electrification or by optimal feed or circular feed, or we can expand by adding an EDH to an existing steam cracker. If you have to go for a new steam cracker, think about H cracker, E cracker, and an R cracker. Please evaluate and make the right decision. And future, it's the sunset for conventional steam cracker, but it is the sunrise for novel olefin technology. And there is transformative innovation coming for future olefins. So thank you. Next slide. Thank you very much for your patient hearing. Thank you very, very much.
Thank you. Thank you, Dr. Maitra. First of all, let me admit that I never thought that I will ever hear a statement called as sunset for steam cracking, and that too from a strong advocate of steam cracking from a person like you. But the very fact that it does so and that you are made to say so implies that there is definitely a push, a very hard push at that, to make ethylene production more sustainable. And I'm very glad that we had a conclave or a webinar on this theme, number one. And number two, we got some new ideas about how this can be done, both in the existing units by changing feeds and adding ethane dehydrogenation, or for new crackers going in for 3 different types of cracking technologies, the H cracker, the R cracker, and the E cracker. So, yes, you are saying so, and the trends that Rajiv Narang also said that we also have ways in which you can reduce the emissions in doing conventional or in doing cracking for olefins production. So the trend definitely seems to have been set into role, and we'll see more of such units. Other than the units that you have already listed out, we'll see many more interest being shown and some new capacities also coming up. Your presentation normally is so crisp and clear, Dr. Maitra, that I wouldn't expect any questions to come on them because you have said and so clearly, and I rightly so, I don't see any questions for your presentation. But if there are any which come in the later course of the last presentation that we are still to have, please be there to answer them at the end of the sessions, and all the presentations are over. We'll have a quick relook at the question answers and wrap them up. We go to the last presentation of today by Mr. Manish Singla. Mr. Manish is working in Jindal Steel in strategy and M&A, mergers and acquisition division, and is looking into mineral blocks acquisition in India as well as internationally. He is working on various projects, including coal gasification and underground coal gasification. His area of expertise includes policy review, transaction, strategy and business plan development, and M&A activities. He holds a master's degree in business administration with specialization in finance, and he has around 19 to 20 years of experience in coal mining, power, steel, cement, and other infrastructure-related sector. Over to you, Mr. Manish, for your presentation. The topic of his presentation is coal gasification, policy initiatives, and challenges.
Thank you, sir. Thank you very much. And I would like to thank Mr. Alok Parti and Mr. Deshpande for inviting me on this platform and sharing my views as well as the topic on this coal gasification. So just confirm me if you are able to see the screen, sir.
Yes, we can see that. Can just, if you can put in the slides more, it will make it more.
Now this is fine, sir.
No, it's not yet in the slides mode. Yeah, it's okay. I think there was a display which showed it has gone into the slides mode. Yeah, you can start now. Maniji, it is visible now. You can start.
For the coal gasification. Yeah, I am audible, sir?
Yes, you are audible. Please go ahead.
Yeah. So the topic of the presentation is coal gasification and what is the overall landscape of the policy for coal sector as well as how coal gasification is fitting into that and where we are in terms of India, in terms of initiatives under which Ministry of Coal has taken under different policies and what are the policy challenges going forward for coal gasification. So this is the snapshot of overall policy landscape for coal sector. The first is related to captive coal block auction as well as allotment. It happened from 2014 to 2020, and it was immediately after the Supreme Court cancelled the coal blocks, which was around 200 coal blocks were cancelled. And the out of that, almost 37 coal blocks were successfully auctioned and 55 allotted successfully. So they are producing roughly around 150 million ton, which is 15% of the overall production. So in terms of policy initiative, the policy of the captive coal blocks was quite successful, especially the blocks which were allocated to PSUs. Now, from 2020 onwards, the captive coal block policy was exhausted, and the commercial coal block policy came into picture. And under this policy, roughly around 140 coal blocks has been auctioned, out of which 11 has started, and which are producing roughly around 25 million ton, which is 2% of the total coal production. And the third policy is related to coal-black methane. Although this is not the initiative by the Ministry of Coal, it comes under Ministry of Petroleum Natural Gas, MOPNG. It started roughly from 2001, and till date, out of 5 rounds or maybe four rounds, around 33 blocks were successfully auctioned, out of which 6 are only operating, which is producing roughly on 1.5 MMBCM, which is not even 2% of the total gas production. domestically. So in terms of policy initiatives for coal-bed methane, we are lacking in terms of initiative as well as the technology front. Out of 6 blocks which are operating, 2 blocks are one by SR and one by Reliance in Madhya Pradesh, and the rest of the 4 blocks by ONGC and oil joint venture. So the production volume is also very less. In terms of policy initiative, the blocks we would say are not very successful in terms of in last 25 years, which the status is as of now. And the last 2 buckets, which is surface gasification of the coal and underground coal gasification, which both of these come under coal gasification policies. And surface coal gasification, there is no separate policy for surface coal gasification. It comes under the coal gasification policy. And there were few plants like Talcher Fertilizer, which has closed now. GSP Angul, which is currently working, and this is the first and only plant which is operating in India now, which is producing syngas from coal after using the washed coal, and the syngas which is being used for the DRI making. And the underground coal gasification, although not much has happened on this, the policy came into 2016, and the blocks were still yet to be auctioned by the government, specifically for which the coal can be used for coal gasification. And we are expecting in another 2 to 3 months, the blocks for coal gasification will be coming on stream, and parties will be bidding for that. So incentive-wise, Ministry of Coal and ministries has offered different incentives in different tranches for promoting the coal gasification. So like in the commercial coal block auction, the incentive of 50% rebate on the final price offer is given if you use the coal for specifically for gasification purpose. And ministry has also earmarked a budget of 8,500 crores, which I will discuss in the next subsequent slides. So coal gasification, it is a compulsion for India, as India's commitment in COP21, then COP26, then COP29. We have to decrease our carbon footprints. And as you know, the coal which is being used, almost 80% is into power, and rest around 10 to 15% in the steel sector. And steel sector is also very, very carbon generating sector in terms of sector which is generating carbon other than power and cement. And that's why if the coal gasification can free some capacity for steel making and using steel DRI, using the syngas, that can reduce some of the carbon footprints. So the introduction of the coal gasification is, it is a technological process in which partial oxidation of coal happens to generate the mixture of gases, which is syngas, synthetic gas, producer gas, and which comprises mainly of CO and hydrogen. And the gasification advantage is, it is a cleaner option as compared to any other option which is being used. The coal is abundantly available in India, especially the coal which is below 300 meter. And few of the technological plants are already operating in India, like GSP Angul, and few of the different plants are under different implementation stages. And for underground coal gasification, there is additional advantage other than surface coal gasification, that there is no need to coal to be mined, no need of ash handling, no need of coal transportation, etc. And it all reduces the carbon footprints as compared to the traditional coal gasification, which is used for surface gasification for making of syngas. But at the same time, there are disadvantages of both coal gasification as well as underground coal gasification. Like as of now, the ministry, the consumption norms for coal gasification is still not finalized. And SIMFAR, along with the CISR, is in process of finalization of the consumption norm for different grades of the coal and for different products which is being developed using this process. And for underground coal gasification, the disadvantage is, as of now, there is no proven technology or the successful implementation in India. for underground coal gasification. There are few pilot projects which are being taken up by different companies, but full-fledged commercial coal block operational coal gasification project, there is none in India. So in terms of potential, out of 378 billion tons of coal resources, around 200 billion ton is already proved resources, and out of which we can say almost 46% is deep-seated. That means greater than 300 meter. So if we say less than 300 meters is generally open cast coal mines, and we are doing a lot of almost 97 to 98% of the open cast also. But at the same time, we are not doing much on the underground coal gasification, and that is why there is a lot of potential to mine that coal which is below 300 meter and use that for coal gasification. So this is the first successful VGF in the coal sector which has happened. So ministry has, Dr. Piyush Kumar has also mentioned, he was on the committee of this coal gasification. So there is a target to use 100 million ton of coal for coal gasification. The 10 million ton was using the pilot projects, and the rest 90% for the commercial coal operation. And ministry has come up with this budget of almost 8,500 crores, out of which almost 4,700 crore has been earmarked through viability gap funding to different companies, and which has triggered the investment of almost 40,000 crores for different states. The biggest chunk is received by PSU companies like Bharat Coal Gasification and Coal India GAIL joint venture. They got almost 2,700 crores of funding, and they are almost spending 27,000 crores of projects using this funding. Under category 2, which was for private sector as well as government PSUs, 3 companies, mainly GSPL, New Era, and Greta Mineral, got this funding of almost 2,000 crores, which has triggered investment of roughly around 20,000 crores. And the third category was for the pilot project, for which 600 crores was earmark, and there was none of the bidder applied through pilot projects. So these 3 plus 2, 5 projects are agreements are already started, and these are at different stages of construction as well as implementation. So we are hoping after this policy, there is that trigger on investment in terms of coal gasification will start, and it will make many other projects viable. And we are hoping on the similar line, a special fund will be given for underground coal gasification as well. So for underground coal gasification, as you are aware, there is the first stage is pilot study, and after this commercial implementation of that study. So when I say pilot study, it means the coal gasification is very, very site specific. We have to select the site, we have to see the grade, and in coal in India, there are different seams. Every seam is having different grade. Every grade is having different ash content, and that becomes a very, very challenging for using some process constant for each type of a coal. And that's why already few projects are under a pilot study project. JPL has conducted a pilot study for Gare Palma Sector 1 coal block. In Chhattisgarh, the pilot study is already completed, and results in terms of technical ground are encouraging. And there are other pilot projects which are ongoing is Coal India's underground coal gasification in Kasta coal block, Jharkhand. GMDC is also planning some underground coal gasification for their coal blocks. Tata Steel is also doing, and there are other private companies which is in the news is like Vedanta or maybe Adani is also doing a few pilot study projects to enter into this space. So we expect the government to kickstart the auction of coal gasification along with the funding, which on the similar lines of VGF, which is given, as well as rebates in terms of royalty. It should not be treated on a similar operations like oil and gas block. Coal is a very, very different commodity as compared to oil and gas. And that's why the underground coal gasification should be incentivized, as this is a very, very risk-taking capability in terms of project capex, very high project capex. Returns are after 6 to 7 years if the project is successful, and there is no successful technology as of now implemented in India. So with this closing remarks, I am hoping that Ministry of Coal will be coming up with coal block auction, especially earmarked for coal gasification in near future in next 2 to 3 years. Thank you very much.
Thank you, Manishji. I think that was a very comprehensive overview of the coal gasification initiatives that are being taken up, as well as those which are yet to be taken up for underground coal gasification. And we definitely find that the thrust on surface coal gasification has started with the two initiatives that have already been taken up. I think funding has also been agreed to with different companies.
Yeah.
And we also expect that underground coal gasification in due course will come up slowly and gradually. So I just wanted to ask you one question. Is underground coal gasification, has it been initiated in any other country worldwide, or is India the first one to take the lead in this subject?
So there are other countries which started this, like Canada and USA and China. They are pioneer in that. But having said that, their results or their technology cannot be implemented, or the results cannot be based on the historical data. We cannot say that same technology will be successful in India, because in India the biggest challenge is the coal is having high ash.
Yeah.
We are having more than 35% of ash, which has to be first washed and then only can be used for gasification. Underground coal gasification, depending upon the area, if the ash content is less than 25%, then only it will make sense to do the coal gasification. But at the same time, we traditionally think if the coal gasification, the underground coal having ash of less than 25%, then it will be suitable for underground coal mining also, and it can be used directly in the steel, which is much cheaper option as compared to funding the coal gasification project.
Okay. Thank you.
Yeah. Thank you, sir.
Thank you. Yeah, Patisam, would you like to add something?
Deshpandeji, I think you can open the thing for question.
Yes.
Well, since all these speakers have given their presentations, so we can ask some questions.
So, okay, let me ask if any of the speakers have had opportunity to look at the questions that they have been put across. We can start with we can start with Mr. Vaidya if he has had a chance to look at the question. Vaidya ji. Mr. Vaidya, you're there?
Muted.
Okay, fine, doesn't matter. We'll come back. Yes, Mr. Oh, I saw him on the screen, but anyway, we'll go to the first. Piyush Kumar hasn't come back, so I think we'll have to skip. Mr. Vaidya is there. Mr. Vaidya, can you take one question which was addressed to you?
Yes, please. I saw that question, the first one, na?
Yes.
Actually, the gentleman is asking whether there is any timeline for, there should be a timeline for, all these
CO2 capture
green initiatives.
Yes.
So actually, let me tell you, there is a difference between energy ambition and energy realism.
Okay.
Now we have all seen that 1.5 degrees centigrade is not achieved, though we have set a timeline by Paris Agreement. Yeah. And so far, there is no CCUS project of that size and magnitude. Maybe yes, but it will come, because finally the need of the hour is, and I've also seen many people say that the Indian coal has got a lot of ash, but that's all we have. That's the reserve we have. So we have to circumvent over that limitation, and we have to find a way out. Otherwise, we'll forever be dependent on the foreign sources for our energy requirements. That is my simple point.
Yes. You're right. I think that's a very correct way of putting it, because there are no easy solutions. Exactly. But you can only try the best suited solutions for that at that time, possible at that point of time.
Exactly. So we have to keep on trying to get a solution out of the whatever resources we have, We have to come out with the answer for that. It has to be tailor-made, customized for my coal.
Yes, absolutely.
Ajay,
Yes.
if I may add something to Mr. Vaidya's observation
Yes, yes,
on,
please go.
why we shouldn't be independent. And
Yeah.
this is to do with carbon capture, solvent, and technology.
Yeah.
Which is for India to develop its own technology and its own solvent is very easy.
Yeah.
We should be doing it, and I have actually commented on this at various forums, even to the ministry.
Yeah.
If we do not take up this initiative now, we will be buying this from the from European and American, and it's not rocket science. We have exploded. We have seen it. It's just taking a little bit of risk, not even major risk.
Yeah.
Taking a little bit of risk. So that's my addendum to Mr. Vaidya's observation.
We have some solvent technologies indigenously available.
Yeah.
Like EIL, we ourselves have offered CO2 absorption technologies or different kind of amine blends, including beginning with conventional DEA, then switching over to MDEA, now activated MDEA. We have tried all kind of solvents, and we have the most optimal solvent solution for each gas mixture today. But yes, it's an evolving technology. You can never say that we have reached the best solution as yet. So we will gradually have to reach the best solution, and efforts will continue. We will need to continue on that. So let me switch to the other question. The next one is for, there were some questions to Dr. Piyush Kumar, but since he hasn't come back yet, we'll switch them to keep them waiting till he joins us. The next is to Mr. Manish Shandilya. Manish, you are there?
Yes, sir, I'm there.
Okay. Did you have a look at this question from Mr. Akhilesh Kumar?
Mr. Akhilesh Kumar has put in, put in a couple of questions. Which
yes,
one?
you can give a combined answer to all of them.
Okay. So so I'll just try to answer some of the questions that he has about carbon dioxide capture has not taken on. That's probably capturing is one aspect of it. After that, it has to be dried, compressed, transported, and then for corresponding to the kind of CO2 that we generate, we must have a outlet for it, which is economical. There has been attempts to sequester it, but didn't work out the economics so well. But otherwise the quantum is so high that capturing it and finding an outlet, that is the challenge. Then there has been a question of what chemicals do you plan to manufacture? So when I said bulks, it is mostly polyethylene and polypropylene. But when we are talking about specialty, then there would be, we have experience of implementing projects in acrylates, oxo alcohols, acrylic acids. And now we have customers approaching us for practically the entire spectrum of derivatives down to C4s and C5s. So that depends upon, I cannot name those chemicals here because they are specific to the client which is talking about. But normally there needs to be a market study done, and the location, when we say it is the logistics of bringing in the feed, taking it out, and how well and what kind of synergy that the operator is getting with the existing refinery in terms of sharing the utilities, sharing the logistics, because these are the items which contribute heavily into the cost. The cost of the chemicals is frozen as per the market, so that is why it's pretty hard to just put a finger on these. But yes, interest is there in LDP, interest is there in rubbers and some specialties as well. Syngas to specialty chemicals may be profitable. Yes, it can be, provided the source and what is the price that we are getting syngas on, what is the quantity, and how far we have to transport it. So these needs to be factored in, which is done through a customized study. Mrs. Varsha Gupta, I've answered that. Yeah, green chemicals. Yes, EIL is working in collaboration with technology providers for SAF and for bioethanol. We have collaboration agreements with CSIR as well as a company called Chempolis. which allows us to provide these technologies to interested owners. And the Chempolis plant is coming up in a couple of months. You would probably see its commercial operation. And the plant with SAF is under execution with one of our customers. Yes. Profitability forecasted for, Mr. Priyam said, profitability forecasted for IREP for integrated refinery petchem complexes considering the current surplus. Well, the choice of the chemicals is important. The bulk chemicals has lot of market still, but yes, it is always a customized answer. But without petchem integration, the profitabilities would plummet awfully. That's for sure. What is the life cycle? Can Mr. Naren Khatse explain what is the life cycle you are considering for design and best? What is the meaning of this question? Sorry.
I think, Manish, what we can do is you have answered sufficiently most of the questions. Now, to do justice to the questions to the others, I'll have to give them an opportunity. So let me now switch to the other
Sorry
speakers.
for that.
Yeah, it's okay. Rajiv, have you noticed any questions that you could answer? I didn't see any questions specifically addressed to you. But in case
No,
you
Ajay, that's because I've answered all the questions, and
fine,
they
okay.
should be in the answered, the 5
Box.
questions I've answered.
Okay, fine. Okay, so I think let me switch to Dr. Maitra. Dr. Maitra, one question. In e-cracker, how do they use C1 gas produced in cracking?
Yeah. Anyway, the C1 gas that is produced, it's not. It's used as a fuel, but generally, if you want to make it completely zero, then that goes to ATR, autothermal reforming, in order to make hydrogen. But that hydrogen, because it is coming from fossil, it is still not sustainable.
That's right.
And then it has to go to CCS in order to make what is called blue hydrogen.
Yeah.
But in general, if you go for C2 cracking instead of naphtha cracking, the amount of C1 that you get is much lower, and hence all this extraneous things become much less.
Okay. Okay, I think that that was quite clear in your presentation also, that the C1 is going to give hydrogen via autothermal reforming. So even if the hydrogen may not become green, you can still make it blue by doing carbon capture. That's the best you could do with that. There's one more question. How are the potentials for membrane separation in a petrochemical industry from energy consumption point of view? Now, this seems to be a generic.
Actually, that question I feel is out of the syllabus, but let me but let me address it.
Yeah.
See, what is happening is, and we have to look at a holistic picture.
Yeah.
Till now, chemical engineering separation always meant distillation.
Yes.
And the reason it meant distillation, because fuel was available to drive the distillation. That means you could fire the reboiler and so on and so forth. But if there is a paradigm change from fuels to electricity as the lowest cost fuel in the market, then we have to look at other ways of separation. And the other ways of separation is either across a membrane, that is diffusion across a membrane, or by having a centrifugal separation. These have not yet become mainstream, but I think as we go closer towards net zero, we will, and when we have more and more renewable power, you will have some novel, innovative way of separating A versus B in terms of, separation. But not driven by fuel, but driven by power.
Okay, thank you. There is one.
There is one. Can I update
Yes.
on this?
Yes, please.
Actually, there is a synthetic polymer membrane replacing heat-intensive distillation, where we can slash the energy consumption by more than 50%. And I said in my talk also that ExxonMobil and Imperial College of London, they
Yeah.
are piloting a project, but basically now targeting for lubricant separation.
Okay.
And it is basically in the pilot stage, but they are very confident that it may see the light of the day, and we can
Okay.
go in for bigger and bigger scale. So that's it. That's what my update is.
Okay. Okay, thank you. Thank you, Mr. Vaidya. This is a generic question put forth by one of the audience. Is there a potential of doing steam reforming on waste plastics? Now, we have seen about pyrolysis being used for waste plastics, but is there a potential of doing steam reforming on waste plastics? Either Rajiv or Dr. Maitra, any one of you?
Yes, we can do that. In fact, plastics with steam, here's a take. When people say that hydrogen reforming is CO2 is not green, what I always say is hydrogen methane reforming is CH4 plus H2O gives CO plus H2, and then the water gas shift. That half of the hydrogen comes from the water.
Yeah.
So, I always contest people saying steam reforming is methane steam reforming is not green. My contention is this: half of the hydrogen is coming from the water molecule, which is what you're doing in any case for by electrolysis. So, same thing for pyrolysis. Yeah, and especially biomass gasification. Biomass, using biomass as feed for reforming, where you can also put in water and extract and break the water molecule. This is a very difficult molecule to break, but you can do it.
Okay. I think Professor Pant, who is to do a complete wrap up of the webinar today, he has been waiting very patiently, and we have covered many topics. We have covered many questions. I know some questions have remained unanswered, but broadly, many replies have been given. But I think it's time that we give him his due. He had a patient wait in listening to all speakers, listening to all their questions and answers. Some of the questions not answered may come up in his replies also, or his summing up also.
Thank you,
so it's over to you,
for
Professor
providing me the opportunity. And first of all, on behalf of Lovraj Kumar Memorial Trust, I take my pleasure to thank all the speakers who have given the time and wonderful lecture, right? The thought process which has come. And also, I would like to thank the HMEL and ONGC for supporting this webinar. Having said that, if I just talk about brief about what Mr. Vaidya has talked about, right, the need of the plasma gasification, how to feel that R&D is already being done. But if you do some kind of energy analysis for this plasma gasification, then we can work on this. And this is very important because when you talk about the, say, MSW, right, gasification through plasma approach, and when you do this plasma or supercritical, that there is another approach where supercritical can also be tested, although presently it is energy intensive, but I think there is a way if we can do, right, it effectively, and I think academia and industrial collaboration is required, where we can talk about the plastic, biomass, and even the crude oil, that is the heavy crude like HGO, VGO, can be mixed with that, and that kind of R&D should be done. And thank you, Mr. Vaidya, for nicely explaining the concept of underground gasification, coal gasification, and also
the critical mineral, because there is a need to extract these kind of critical minerals from the coal itself or fly ash itself. That is also, I think ministry is also supporting this activity on critical mineral mission, because India is importing 100% of these kind of critical minerals or rare earth, which would be the need of the future. Thank you, Mr. Vedya, for this. Among the technical sessions, we had the 5 technical speakers, and I again thank you all. So Mr. Piyush Kumar from now MD of Bharat Gasification, he spoke about the coal gasification, and again there is a need when we talk about whether it is oxy gasification or oxy steam gasification, and which is required, because when you talk about the intent bed gasifier, mostly used by where the ash content is less. But when you talk about the highest content coal, I feel that because we were also working on this coal to methanol project, which was supported by Department of Science and Technology, and we handle this 20% ash coal for this coal to methanol, and 1 TPD notional plant is already running successfully, for which now we are working on now CO2 to methanol also and dimethyl ether. So these kind of R&D are required, and different groups like NTPC is also working, and CSR labs are also working on these kind of approach, and 1 to 5 tons of these kind of coal gasification, followed by conversion of syngas to methanol, dimethyl ether, and which can be further taken to the olefin. So that is coal to olefin, coal to hydrogen. So these are the thought process. I think that is also to be done in future based on this technology. And it was very well explained by Mr. Piyush Kumar, which is the need of the hour in future. Mr. Manish Sandelia, again from the Chief General Manager EIL, and he talked about the integration of refineries and petrochemical, because there is a need to work on that. Few gases, which are coming, refinery of gases which are coming, how to utilize them effectively, that can happen only when we can have the integration among this, because 22% carbon dioxide generally, which is present in the flue gas, and that is again, we have to capture it and convert it effectively. At the same time, when you talk about the need of the refineries and petrochemicals, so crude to chemicals will be very, very important in future, and how this crude can be converted to olefin in an effective way, because we have to find out the process also relatively green. It may be some number of green, which we have to define, because the hydrocarbon sector has always a challenge in terms of making the process entirely green. And I also feel that the coal will still remain in future also, whether the percentage share may be less. Same thing for the crude oil also, it will remain in future. The percentage of this, which is very small, I feel, so 20% to 30% of this, of biomass based, which is available, but not in that much number, which will fulfill the entire demand of the energy, which is increasing exponentially. And when we talk about the net zero by 2070, I think a lot of things are to be done in that how we can use, or refineries or petrochemical can use a part of this bio oil, maybe biomass pyrolyze, and can add it with the crude oil and then do that. Or we are also doing some kind of coal plus biomass plus plastic, with the question Mr. Ajay was also asking. So this can it possible, you convert plastic into oil and then reform this oil, just like a traditional steam reforming of these kind of bio oil compounds. So that also already lab scale testing and lab scale catalysts have been developed. But when you talk about the stability of the catalyst, when you talk about the pilot scale studies, I think a lot of things are to be done in this area. But this is also very emerging area when we talk about crude to chemical, and look at the opportunity of the kind of something blue hydrogen or white hydrogen also in future, because that was also the part which was raised by Mr. Rajiv. And thank you, Mr. Manish, for explaining it in a nicely way. And thanks, Mr. Rajiv, who had been for a long time. We were working together, as a this IICH membership, and he nicely explained about, because we talk about the process optimization. Because when you talk about refinery, petrochemicals, there's a need to work now miniaturization. This is very, very important. Even we just talk in terms of tabletop reactors, instead of having the large refinery, and we convert it into, although this may be a dream, but maybe in future it will come true, that you have to make a compact design. You have to look at the when you talk about the Internet of Things, Industry 4.0, 5.0, and using the tools like artificial intelligence, because if we can minimize the losses within the system, do the exergy analysis within every unit, and find out the mass balance, heat balance, and wherever losses, using this kind of new tools, I think those studies are required, and that will reduce the size of these reactors, like steam reforming. When you talk about the number of tube bundles, just like methane reformer. So we have to find out that how can we reduce this, because reducing this kind of size of the reactors, reducing the unit operation in the process system itself will be huge, huge amount of in terms of the improvement in the overall process. And Rajiv ji explained it very nicely. And he also talked about process economics, which is very, very important when we talk about the transformational research and converting the lab scale data, pilot scale data to a field scale or a commercial scale. I think there's a need to work on it. And then the electrification would be very, very important, because when we talk about the low carbon product, so presently whatever natural gas or other kind of heating media are used, can we replace them by the electrification? That is also, or at least part like solar energy, biomass-based energy, biomass-based pyrolysis or gasification. So those things also we have to think in future, and that is the small modular reactors. I think these will be the need in future, and also the carbon capture, mineralization. Those things are also equally important. Then the fourth speaker was Dr. Partha Mehta, and as Ajay was also talking, very meticulously he explained the trends in the refineries and petrochemical. And the olefin, when we talk, how these olefins will be produced in future, maybe biomass to olefin, yes, it will be a future when we talk about how biomass to syngas and syngas to olefin, maybe coal to olefin also, this should be a thought process, and natural gas to olefins. So these are whether it is oxidative coupling or methane. So if we can have, then the biogas can also be converted to olefins. So these things are also, I think, a part of these green energy or green feedstock should be used. And I'm sure that this will come in future. And at the same time, when we talk about low emission, I think again, electrification, feed optimization, and circular feed, these will be the need of the hour. Again, there may be a biomass will play a role, along with other feedstocks which can be used, and that is also need of the hour. Then he also very nicely explained about H cracker, E cracker, R cracker, and that is also, I think, when we talk about feed optimization and naphtha to olefins, in between, when we talk about the reforming of naphtha, a lot of thermodynamics plays a big role. I think if you just look at that reverse water gas shift reaction also in the process, I think we will have the better process, in terms of the productivity and selectivity. And that's why RWGS is also very, very important. And catalyst will play a big role in all these processes. So future in terms of the catalytic market, I think the indigenous catalyst should be developed within the country. And for that, again, the academia role would be very, very important, along with the R&D of the refinery and petrochemical. So their biomass, waste plastic, and supercritical water, so a lot of lab scale studies are being done. But the material of construction is still a challenge, You need to have a material like titanium based or alloy based. So are we ready to take that challenge? That is one of the, and the very high temperature like 220 bar plus or 800 degrees centigrade temperature which is required. So that is a kind of challenge, and that's why the water electrolysis, the sulfur iodine process, these things are also a challenge when we talk about hydrogen from water by sulfur iodine process, which is already pilot scale studies are there, but commercialization is coming up a challenge because it requires a very specific kind of material of construction. But I think the industries are coming forward to take that challenge also, and that is where I think the very nicely it has been explained by Mr. Mehta. Thank you, Dr. Mehta. And finally, the last talk, Mr. Manish Singla, again, a wonderful talk on this, where you talk about the availability of Indian coal and how the gasification of these coal and policies, which are very, very important, underground coal gasification versus surface coal gasification. And then how this, when you talk about the carbon emission, because that is very important, that carbon capture and utilization within the system, utilization of fly ash, that is also need of the hour. So where again, lot of R&D is required. So now how the coal impurities and impact of the coal impurities on gasification, followed by the product which is coming at the end, because coal to methanol, coal to hydrogen, because sulfur is a big challenge. And same thing with ammonia and volatile matters. So I think the purification of this flue gas along with carbon capture is still a challenge, and this becomes a costly affair. So that's why the gasification, also advancement in gasification, it can be again a supercritical gasification or supercritical coal steam reactions under subcritical, supercritical or hydrothermal. These may also be tested when we talk about coal to chemicals, right, which can be through gasification route or through hydrothermal conversion route. So that will also be very, very important. So if I just look at the summary of this, because what CO2 hydrogen integration will be required. That's very, very important. And if you look at the data again, the total energy, which is generally when you talk about the greener CO2 reduction, because CO2 reduction is very, very challenging. So thermocatalysis versus photocatalysis versus electrocatalysis. So all these processes, although thermochemical is already being practiced by industry, but I think the future may go towards the electrochemical conversion also, because the total energy when you talk about through thermochemical for carbon dioxide capture itself is between 125 to 400 kilowatt hour per kg of the product when you talk about CO2 capture. And if you look at electrocatalysis, it is between 35 and 100 kilowatt hour per kg of the product. So here, there is a huge difference. But the only thing that how are we going to design these kind of electrocatalytic reactors or gas diffusion layers, right, when we talk about the challenges. Then CO2 free hydrogen. So steam methane reforming, lot of discussions have been made on this. So if you look at energy consumption in kilowatt hour per kg of hydrogen, from the steam methane reforming, which generally produce 9 to 10 kg of carbon dioxide per kg of hydrogen. And this is around energy consumption is between 3 and 4 kilowatt hour per kg of hydrogen. But if you look at methane pyrolysis, because that could be the another approach in future for capturing the carbon in the form of carbon nanotube along with the hydrogen. So you need not to work for a CO2 capture unit, but presently the cost of methane pyrolysis is around 7 to 8 in terms of kilowatt hour per kg of hydrogen. So this is where we have to find out, right, biogas decomposition of methane, separate the carbon dioxide and decompose the methane, and you will have green hydrogen, right? That's very important for the future. And if you compare it as of today with water electrolysis, there are a lot of challenges with water electrolysis. So it is around 50 and 55, between 50 and 55 kilowatt hour per kg of hydrogen. So the future may be the water electrolysis, but as of today, there are a lot of challenges when you talk about the cost of hydrogen, which is being produced through electrocatalytic reaction or through water, right, electrolysis. So still, I feel that this fossil derived feedstocks, if you properly capture the carbon dioxide, if you look at the optimization of these processes, that will be, I think, the most effective trend for refinery and petrochemical. So if we talk about the take-home message for the young generation for research as well as the R&D, I think there is a need to increase the petrochemical and refinery and petrochemical integration, which is a growing demand. And that's very, very important, that quality of the refinery product is to be improved. So there is a need to increase the digitalization, as all the speakers have also said. So AI-based process, in industrial Internet of Things, advanced process control, that is also required. Then focus on sustainability and efficiency of the process. Crude to chemical, of course, would be the future. We should look at that. Capacity utilization, energy transition, and environmental regulation is also the biggest challenge for all refineries, petrochemical, and coal-based industry. So I think the coal conversion will be also, if we talk about improvement in efficiency, reduce the emission, and co-firing of the biomass and advanced gasification technology, these can be adopted. I think that refinery and petrochemical, they should take it for the future. Minimize the carbon dioxide emission, that we have to find out the way. And most important is the recovery of the heat from, say, coke making process. If we can integrate these heat, right, capture it and integrate within the system, that will definitely be helpful for the future. And valorization of coal byproducts, right, like fly ash, that is also important. So these are some of the thought process from my side. And once again, I thank all the speakers for sparing their valuable time. And I thank the committee of Lovraj Kumar Memorial Trust for inviting me and providing me the opportunity to give the vote of thanks. So I thank you all, everyone, And I also thank all the participants. There are more than 170 participants I could see off and on there were, and those who participated throughout the session. So I thank all the participants also for giving the time. And I am sure that the question answer session and the interaction with the speakers must be beneficial for the students as well as the other scientists and the industries. Thank you very much.
Thank you,
Mr.
sir.
Pant. Mr. Parthi, would you like to say some last few words as chairman of the technical committee for the webinar?
Well, I can only thank all the speakers, Mr. Vaidya, Singla, Mr. Chaldiar, Mr. Naran, and of course, Piyush, Dr. Piyush Kumar. Well, it was an exciting seminar where a lot of issues have been brought up, right from the issue of coal gasification and the problems with the Indian coal, to, I think Vidyaji mentioned about the modular reactors, and one would like to certainly see that progress, but unfortunately, the policy issues are pretty ticklish in that area, and it is taking some time to come to some conclusion. We hope that they come out fast. Then, of course, the whole issue which Dr. Pant covered on the petrochemicals. And of course, one started, one got a thought that, like we talk of recycling and a circular kind of economy. I just recently saw an excellent article written by somebody from the Tatas. You actually said that by 2050, more than 50% of steel will be basically from recycled. And that kind of thing is what one looks forward. Maybe, I don't know, Professor Pant could probably comment more on it, but to look at it from the petrochemical side, plastic waste, the biomass, and various other ways of getting back into that whole idea of a cycle economy. I think we are basically trying to find technological answers to how we can kind of minimize dependence on new and new, like taking out oil or using coal, try to reduce it by some means. And some of the issues are, these are the solutions, I think, mentioned by practically all the speakers. So I think it was a very, very exciting webinar, and though I don't know much of the chemistry of the chemical industry, but even then it was exciting listening to policy issues as what is required to be done, not only at the commercial level, maybe at the government level as well. So thank you very much once again.
Thank you.
We are, of course, somebody did mention about rare earths and special metals. I think, if I'm not wrong, Deshpandeji, we've also decided to have something on that in the coming months.
That's right.
We look forward to a talk on that particular subject, which is becoming extremely vital.
Yes.
Okay, thank you very much once again, all of you.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you all speakers, and we are very glad to have all of you accepting our invitation and presenting your thoughts here. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you. Bye-bye.
Bye-bye.
Good morning. Just getting ready to fly to office. I work for ONGC and I am an energy soldier.
They are those who serve the nation in a different uniform, against different odds, on a different platform. These are the energy soldiers of India. Over 26,000 dedicated souls of ONGC, devoting themselves every day for fulfilling the rising energy aspirations of 1.42 billion Indians and bringing India to the world energy map. India's leading company in the field of oil and gas exploration and production, geosciences, renewables, has its presence across the entire hydrocarbon value chain. ONGC is a Maharatna, creating immense wealth for the nation. Investing heavily in green energies, ONGC's efforts are an integral part of India's future roadmap, which includes discovering opportunities in renewable energy and low-carbon sectors. It is always exploring and adopting latest technologies, offering numerous opportunities to grow, which empowers projects to transform a significant portion, ranging from 40% to 60% of the feed crude into chemicals, enabling the nation to meet its petrochemicals demand. Fostering a great work culture, ONGC offers not only a great work environment, but also the best compensation packages in the industry. ONGC is not just among India's best places to work in. It's a place that believes that best has no gender. It's why gender equality is paramount and sacred to us, as is the feeling of truly belonging to a family, bound together by a value system that encourages and enables us all to achieve our best. A best that is nurtured by challenging ourselves even beyond the workplace. From exploring deep seas to scaling the top of Mount Everest, ONGC knows no boundaries. We are ONGC, India's most prosperous energy enterprise, with overseas footprints in 15 countries, where human excellence meets cutting-edge technology, where a progressive work environment promotes inclusion and equality, where interdisciplinary experience keeps work ever interesting, where a 7-decade track record of amazing the world with successful oil and gas exploration programs inspires everyone to go ever higher. If you are young, passionate, dedicated, zealous, explore the many opportunities at ONGC. Be part of a legacy that's always making history. Embark on a career that will instill a sense of pride throughout your life. Come, be India's energy. Let's together build our nation.
India, among the biggest energy consuming nations, its appetite for energy is growing at a pace with its strong growth trajectory. Fast-paced development also means that the responsible nation contributes to a prosperous Indian society. ONGC, since its inception in 1956, has made pioneering endeavors to realize the vision of a proud, self-sufficient, prosperous nation by providing affordable energy. breaking the century-old myth at the very early days of its foundation that no significant oil could ever be found in India today. ONGC is successfully producing oil and gas from Mehsana, Cambay, Ankleshwar in Gujarat, Krishna Godavari and Kaveri basins in south to Assam and Tripura in east. Of course, from Mumbai High, the biggest discovery made in 1974, which brought India prominently on oil and gas map of the world, and later significant discoveries of Hira, Neelam and Ratna fields in western waters, and the Baseen field discovery in the western offshore, which remains thus far the largest gas field of India. Today we move further and deeper, adopting latest innovations of deep sea technologies for breaking the challenges of depth, high temperature and high pressure, to bring to production from new gas discoveries of eastern offshore in Bay of Bengal and in Kutch offshore. The latest gems in the series of discoveries include the Bengal Basin that was dedicated to the nation in December 2020. The field is slated to produce rich hydrocarbons, promising further developmental activities in the region. This is the 7th out of 8 discovered basins of India ONGC has put to production. The Vindhyan Basin in Hatta in Madhya Pradesh is the 9th basin of India and the 8th basin discovered by ONGC, which is ready for commercial production. Breaking the technological barriers with adoption of latest innovations in oil and gas engineering and a focused and motivated talent pool, ONGC continues to be a global leader in the E&P sector and one of the most valued Indian national energy company. An equal opportunity employer, ONGC is among the most admired organizations of the country and among the best places to work. In recognition of its role as a responsible corporate leader, ONGC's social outreach initiatives have made positive, tangible difference to the society it engages with, and its efforts are emulated and quoted for inspiration widely. Aspiring to establish its presence in the entire hydrocarbon value chain, ONGC has today created a niche for itself in not just oil and gas, but refining, LNG, petrochemicals and power. ONGC Videsh Limited, the country's largest international oil and gas company, having widespread global participation in oil and gas business, has been contributing significantly to the revenue growth of ONGC. Relentlessly marching ahead with breakthroughs that fuel our journey to realize the vision of a prosperous India.